seconds. Just be at your seats. Okay. Should we begin? Really? Should we begin? Yes. Come on, guys, we are students, huh? Should we begin? Yes. Okay, last time. Should we begin? Yes. Awesome. So, we are here at one of the biggest education programs that this country has ever seen when it comes to Web3. And this is just the beginning. I'm sure we all are hoping more right now, right here. We are lucky to have the opportunity at our disposal, and IBC Media, led by our CEO, Mr. Abhishek Pitti, promises to equip students with the necessary knowledge and skills that will take you, dear students, to the next level. My name is Deepak Singh, and it is my pleasure to extend a warm welcome to all of you present in Tech Mahindra and all of you friends who are joining us online on IBC Media's YouTube channel. It is humbling to be your host for today and for the coming days of this entire Hackfest. Please accept my namaskaram. Before we begin with our super informative sessions, I would like to give you a context of what you are about to achieve in the coming days through this Hackfest. As a student, I am aware there are many worries that you have to face. We all have humble beginnings, and Web3 may be new to most of us here, even though we might have some idea, but we are still at a nascent stage. Even if you are new to this space, it is just a knowledge gap. And if you are able to remove that knowledge gap, then the entire world is going to be at your feet with jobs and opportunities of your lifetime. I am sure everybody here recognizes these challenges, and that is where we at IBC want to help you all with the right information and knowledge. This knowledge, dear students, is completely free, so make sure you make the most out of it. Today, what is happening in blockchain is creative madness, and in words of my CEO, you just need to put a method into this madness, and then you will exceed your own expectations. You are not just participating in a state-level education program, rather, you are now participating and becoming part of a global competition. This experience will be enriching for you. From here, in the next couple of days, you will be able to make decisions regarding your career and take up bigger ambitions, such as entrepreneurship. Here's a quick fact for you. The demand for blockchain engineers has grown to over 500% in the last couple of years. And that's a fact. And here's another interesting information. The demand for blockchain engineers is more compared to the number of engineers that are available currently, which means that there's a massive resource gap. Now the question is, who is going to fill these resource gaps? Can anyone here answer this question? Does anyone know here who is going to fill this gap, this resource gap? No? Okay. I think you might be surprised with the answer. The answer is you. And that's why we all are here. And you, dear students, you have to take this opportunity and get the maximum out of it. What, according to you, would be the global average salary of blockchain developers who are having an experience of about 2 years? Okay, let me just ask it this way. Raise your hand if you think it's above 10 lakh. Okay, lot of hands. Okay. Raise your hand if you think it's above 20 lakhs. Okay, less number of hands. All right, raise your hand if you think it's above 50 lakhs. Even less hands. So that's the average salary of global blockchain developer. And some of us in India might not agree, but globally that's the average that we would say that blockchain developers are getting, and with the experience of 2 to 3 years. So this is the perfect time for you to be part of the blockchain revolution. During this Hackfest, we are going to start with the basics of blockchain and gradually progress towards more advanced levels where we begin building amazing things. It is vital for you to be available for the entire Hackfest. Obviously, you guys know that. I mean, the colleges would have made sure that you know that. It is vital for you to be available, as I already reiterated. So, and also, especially for our students who are online, the same goes for you as well. So let me proceed and give you an overview of our schedule today. We will be we'll be starting with our introduction on blockchain, then we'll move on to functional use cases, then layer 1 versus layer 2, and then we'll cover blockchain distributed database, and finally, blockchain platforms landscape. Okay, it won't sound as boring like right now it might be, because our presentations will be much better than how I'm saying it. This is going to be a long and eventful day, of course, full of learnings and incredible knowledge. I am sure we all are amazed. There couldn't be a better moment to thank our sponsors and partners, without whom this event would not have been possible. So I want to take the opportunity and thank the government of Telangana, Task, T-Hub, Tech Mahindra, Polkadot, which is also IBC Media Continuum's headline sponsor. We have Chingari, Morales, Nitro Network, and finally, Federal Network. It's time now for us to begin our first session, and before that, I would have to make a quick and important announcement. It is a sincere request to all of the students to kindly join IBC Discord. We have communicated with you the invite links. You will be getting it if you haven't received already. And all the students who are joining us online, the information will be put on the live chat in the next couple of minutes. We request you to divert all your questions to the Hackfest channel on our Discord server, and our experts will be answering them and taking them one by one. Now, without any further ado, let us begin with our first session, which is about Introduction to Blockchain, the journey so far. Blockchain got its reputation with the advent of Bitcoin in 2008, a peer-to-peer transaction infrastructure where digital transactions started taking shape in a form of digital currency exchange, and all of it without any intermediary. Fascinating, isn't it? I'm sure you would love to hear more about it, and there couldn't be a better speaker to speak about it, and I want to welcome our first speaker, Mr. Shivam, to the stage to talk to us more about it, and I want you all to welcome him with a huge round of applause. Can we change to the presentation, please? Guys, presentations here.
Yeah. Check, check. Can you guys hear me? So GM, I am Shivam. I'm currently working in events and product team of Morales. I'd like to talk a bit about me and my journey till now. So I've just graduated recently from a college in Chennai, Weltech University. And I started in Morales as a meme lord. So that's something that I love to share as the first thing when I start talking about me, right? So just to give you a context, like if you are in blockchain and if you are contributing, as the MC said earlier, right? If you are in the space and if you are contributing, there's a lot of opportunities. And I would love if you guys be very attentive and let's ask any questions that you have and join the Discord, as you said, right? Because I cannot answer all the questions once we start taking up, but yeah, join the Discord, ask there. And yeah, let's talk about blockchain. So we'll be starting with the very basics, like what is blockchain, and we'll be just covering why do we even need blockchain? Like what the hell? Why do we need another new technology at the place, right? So let's get in. So first thing is, what is blockchain, right? So I would like you all to write it on a paper. What do you think is a blockchain? Just give me a second, some tech glitches. This is good. Yeah, so just write down on a piece of paper like whatever you feel is blockchain, and once we are done with this talk, right, it would be interesting to see like what did you guys thought of in the start and then what it is, right? So I'll just give you 10 seconds to write it. Okay, I see a lot of people writing, that's great. Okay, let's just now go with the slides. So yeah, what is a blockchain? So the most basic definition that I like to give to any computer science engineer is just imagine a set of blocks formed by hashing and connected in a chain, right? So I'm not sure if you have been through your data structures classes and if you're too much interested in or not. But if you know what's a linked list, right? Assume blockchain is a linked list where each the element of that linked list is like a block where you have some data and it also has a hash of the previous block, right? And why do we need that? We'll explore it later. Now, why do we need blockchain, right? So to know why do we need blockchain, we need to understand like what's the problem with the current centralized ledger system, right? So if you see, that is the architecture of current centralized systems. You see you have a centralized database, or we call it server, in the center, and then you have all the clients around it, right? This has a lot of problems. If you see, this has a single point of failure, right? Like let's say if the centralized system that I had right here, right? If that stops failing, all the clients will receive no response, right? So it has single point of failure. If you see, another issue is censorship risk, right? Let's say if this centralized server wants to censor it for some specific client, they can always do that, right? So there's a lot of issues with the centralized ledger systems. Let's just go in each of them one by one. So if you see for the centralized for the single point of failure, right? You have seen a lot of examples. Like you have heard when WhatsApp is down. You have heard when let's say a banking system is not working, right? The problem is they can always be distributed. Let's say like instead of using just one centralized server, you have multiple servers across multiple geographical locations and all that. But still the point of contact is just one, right? If that's down, then basically you cannot just access the application. And that's something very beautiful in blockchain. Like it can never be down. Like maybe it can be slow with a lot of congestion, and there's layer 1 and layer 2 talk coming up, which we'll talk about it, how you can solve that. But yeah, it can be slow, but it's never down. So yeah, let's talk about the next point, censorship risk. I'm not sure if you guys have faced this, but I've faced it a lot. Like sometime I just post a basic Instagram post that's just about currencies and how you could maybe like get started with trading currencies online, and Instagram somehow feels like, okay, this is a sensitive constant. We don't want to show that. And there's no particular way you could figure out, like it's just their own privacy policies that they follow, right? So since it's centralized, this can happen. Like you can just post, it's their platform, it's them who own all the content that you post there, right? So they could just censor anything. Next thing is they have CRUD. So this is actually a feature in database, like you can create, read, update, and delete. But in some systems, this is actually a problem. Like if you see the traditional banking system, right? It follows the CRUD mechanism. Like you have an account balance, you can just go and update it. You can just go and change it to any number. Basically, it's not that easy, right? You cannot just go to like Axis Bank is like, okay, just change my wallet, like my account balance from 10 rupees to 10,000 in the account. But yeah, it's possible to do that, right? So they have CRUD. This is one more drawback as I see, because like you don't need to have CRUD in all the systems, right? Like let's just talk about the account balance one. Instead of just following the update model, let's say whatever transactions you do, right? Initially you had 100 coins. Let's say you spent 10 and then you had extra 20 or something. instead of just updating a one single value in the database, if you just go and add it at all, like maybe if there's a negative number, you subtract it. But yeah, if you just calculate it all and show it, that's much better approach, right? Because in that specific way, no one can go and edit it, right? If that makes sense. So yeah, they have CRUD, and yeah, they could just delete your Twitter account. That's one thing as well. I've faced this a lot. Like I had 2 or 3 Twitter accounts which I used to talk about blockchain. So it's those posts were basically just around the financial aspects of blockchain, right? Because I love finance. So those posts were around like how you could get started in trading and what coins are good to trade and all that stuff. And Twitter used to like somehow not like it. They just delete my account. And because they own it, right? They are the centralized entity here. That's like all the thing that I do, all my accounts, all my posts, they are on a centralized server, so they can do it. And yeah, they have high cost of transaction. This is not exactly because of the technology, the centralized ledger system or the database or whatever database you're using, but this is because of the system, right? Let's say if I have to send money from India to US, right? It costs literally 2% plus 150 rupees at least. It's not just because like of the technological cost, right? It's because of the systems involved. Let's say if I transfer my money to America, it's like my bank communicates with a bank in America and they have a local bank which will find the account and they will do all the transactions. There's a lot of process involved, which makes it a lot costlier. And yeah, they're very, very slow. Like if we take the same example, if you're transferring your money from India to US, it takes at least 5 days. Like 5 days is a lot. Like trust me, it's a lot. Like you can learn hypnosis in 5 days. You can learn Indian cuisine. You can learn English, and basically you can learn singing. And some ads even say you can become product manager. Like that's a lot of stuff to do in 5 days. So that's not good, right? So yeah, these are the main problems that now we see are with the centralized ledger system, right? Now let's just see how we could solve it. So if you recall, it all started with an architecture diagram that we saw, right? We had a centralized server or database system in between, and we had all the clients around it. So look at this. This is like architecture of a decentralized system. So instead of having a central server here, we have like all the servers, they are all like all the systems, and they are all communicating with each other in the network, right? So yeah, this solves all of this problem basically. Let's just see how it solves all of this. So if you see the diagram here, right? Like the architecture diagram here, just keep this in your brain, or maybe if you want, just draw it in your notebook, because it will be much easier when we discuss how it solves those stuff in the next slides, right? Oops. Yep, right here. So if you saw in the architecture diagram, right, we didn't had any a single point of failure, which is like, let's say we had 4 nodes there, right? Top, bottom, left, and right. Let's say you just remove the left one. You still have 3 computers or 3 systems in the network which are connected to each other. So it's well off on its own, right? And they don't have any censorship risk. Let's say I am the top node, or I am the top system in the architecture, and I just don't want to publish my report cards because I love to do that. When I was in college, I had like multiple arrears, and whenever we used to get results, I'm like, okay, let's not share this with my family. So let's say I'm that top node, right? And I don't want it to be shared with other people in the network. But that cannot happen, because when you get a data in the network, it's shared with everyone in blockchain. And anything that gets in the system, that's like any transaction that's get approved in the system, that's also done with consensus. We'll see more about it, but yeah, you know, there's no censorship risk here, right? And then there's no CRUD. Let's say there's a new transaction that has been recorded on chain, right? You cannot just go and delete the transaction from chain. Let's say a simple example, like we all have a copy of chain where, let's say I just have 100 rupees in that, right? And I just want to go and update it to 1 lakh rupees or something like that. I can do that on my chain, right? On my blockchain data structure that I have. But it is not updated to all of you. If I have to do that, I'll push it, and we all have to agree on a consensus that, okay, yeah, this makes sense. So it's not that easy. Like CRUD is basically not possible in blockchains. And yeah, they don't have any high cost of transaction. This will sound very like strange, because if you have seen a lot of memes on Ethereum, right? It costs basically like $80, $100. That's like 7,000 rupees just to do single transaction, but that's because Ethereum is a layer 1, right? No, Ethereum is a layer 0 blockchain, but yeah, the thing is like you can build layer 2s on top of it, like on top of Ethereum, like Polygon is there, right? Like Polygon is layer 2 on top of it, and it just reduces the cost of transaction a lot. And yeah, they're very slow as well. They're not at all slow as well, sorry. Blockchains are not at all slow as well because yeah, again, let's just take the same meme example. If we see Ethereum, we feel that it's very slow, but it's not. Like if you see the layer 2 that's on top of Ethereum, right? That solves that problem. And if you see this on a global scale, right, like even if you compare Ethereum's transaction taking 5 days, it's still better, 5 hours, it's still better than 5 days of transaction that you will do just to transfer your value or the asset that than the features of blockchain, right? Like it's a mesh topology. Like if you guys are interested in networking, it's a mesh topology instead of a star, so data stays with everyone in the network. And it works with the consensus of the network as we discussed, right? Nothing can be added on chain without everyone agreeing to it. And it's immutable, so you just have create and read here. And it has it has very low cost of transaction. Like if you do a transaction on Polygon, like if I'm sending money to anywhere to anyone in the world through Polygon, it just takes like 50 or 60 rupees. So that's very cheap. And they're very fast. Like the average time to get a confirmed transaction on Polygon is like around a minute or 2. So that's fast as well. And yeah, it removes the need to trust, right? As we just had in our introduction, like when MC was sharing about it, right? When you have trust in a system, it's like we all need to just be dependent on someone, and based on what they do is just that system. So you just remove the trust, so it's like everyone is aware of what's happening on chain and everyone is responsible of what's happening on chain. So yeah, let's just discuss about the architecture of blockchain. This is just a theoretical knowledge for the first one. Like the first block is called the Genesis block on the blockchain. And data is stored along with a hash of previous blocks. So if you see as we discussed, right, linked list data structure. So just imagine a linked list data structure and all of these blocks are like the nodes in your linked list, right? So if you see, these contains 3 specific data. Like it could be your wallet. It is actually a wallet name, which I've just replaced with JSON. And let's say on the Genesis block, JSON gets 20 tokens or some 20 numbers of stuff. And then it will also have another thing, which is the hash of the previous block. But since it's the Genesis block, the first one, right? You see null there. And if you see in the next block, let's say a new transaction has been added. Everyone approved it that, yeah, this transaction is valid. This transaction can go through. And it gets added. So JSON pays somewhere 10 coins or something. And then there is a hash. That's not exactly a hash. That's just a random number that I just pulled and added it there. But in let's say on all the different chain, it's basically hash based out of a specific algorithm. Like on blockchain, it's a SHA-256 hash. On Ethereum, it's like ETH hash. So we have that hash with it. So it points to the previous block. Like JSON spent in -10, but the previous block is this one, right? And similarly, like all the next blocks are stored in the same way. And yeah, hashing of previous block, like you saw we hash it, right? Like the previous block and add it in the same block as well. Why do we do that? To make sure it's immutable, right? Because let's take a simple example. Like first block, we have ABC and we have null value because there's no block before it. And then we have DEF, which has a hash 1, 2, and 3, right? You could easily understand why that's 1, 2, 3. A is the first letter, so I just had it 1, 2, 3, basic encryption. So next we have GHI and JKL. But let's say if I try to change a data, what happens, right? If I just change GHI to HHA, right? Which is not the exact hash. So it just breaks the chain there. Like that's why, like if you just update a transaction and try to put it on chain, everyone can just verify it from the previous block and they will know that, yeah, it's a fraudulent transaction. So it just breaks there. And yeah, any data before getting added to chain gets checked by miners or validators. So we talked about the consensus, right? Like let's say you want to put anything on chain, then we all have to agree about it. So those are actually the miners, or in a proof of stake network, those are called validators who need to like verify whether the transaction is valid or not, right? So let's just take a simple example here. Like Jason had 20 tokens in the start. He spent 10, then he spent 5, and then he spent -10. You see that gray chain thing there, right? Why I have it is like whenever, let's say that transaction just came through, it doesn't just go and get added to the chain directly. It first stays in something called mempool, where miners pick it up from, or validators pick it up from, they verify whether the transaction is valid or not, and then they add it to the chain, right? So here you obviously know the math isn't mathing, right? Like it doesn't work like that. You had 20 and you're spending 25. So that doesn't get added. So yeah, any data that gets added to chain, it gets verified this way. And yeah, we talked about encryption, right? Like ABC was 1, 2, 3, and all the data that we have in the previous block gets hashed and stored in the next block. But what's basically encryption and hashing, right? So, sorry, encryption is just two-way route, right? Let's say we have test here. So I've just encrypted into the alphabetical numbers that we have, like T is represented as 20 and E is 5, 19, and 20, right? But hashing is not that. Hashing is just one-way route. Like I can take that data like JSON plus 20, and that's exactly the SHA-256 hash of it, and I can get that hash. But I cannot take that hash and get back the data. So that's basically a brief about what's encryption and hashing. And yeah, we have three main parties in blockchain, as we have already discussed now. One is the general public, or all of us who are using it, right? Let's say I'm the one who is sending the money from here to someone in US, my friend. So we are all users here. And then we have something called nodes, because if you want to read data from blockchain, right, then we use nodes basically there. And then we have on top something called validators, those who actually validify all this transaction. So basically all the validators are a full node. Because let's say I want to be a validator and I want to approve a transaction that's coming in, or say whether this transaction is valid or not. So for that I need to know the whole chain, right? I need to verify the whole chain, because if we just see the fun example here, right? If I don't have whole chain and I just see Jason is spending let's say 10 coins or something, I cannot say whether it's a valid transaction or not. So to be a validator, I need to hold the whole node. So yeah, these are the three parties that we have here. And yeah, working of blockchain. So transactions are shared with all the participants in the network. So let's say if I just do a transaction now on Polygon, so that gets added to the mempool. Everyone can see it, anyone can pick it up, and they can verify whether it's a valid transaction or not. Once that's valid, it just gets added, right? So to do this, actually they need to ensure that there's two things. First, the transaction is historically compatible. As we saw in the fun example, right? It was not historically compatible. If you just total down the amount that was being spent there, it was more than how much he had in the wallet, right? So it was not compatible, and it has to be fully authorized as well. This is also another great stuff and another great thing I would say in blockchain, right? You hold whatever you have. It's not the case with your traditional banking systems. Let's say whatever you have in your UPI can be spent with the bank's permission. You do have your UPI PIN that you enter there, but it's not exactly your property, right? It's with the bank and you can spend it. But whatever is here, right, on blockchain is completely yours. No validator on chain, or maybe let's say, even Sandeep Nailwal cannot do a transaction on your Polygon or Ethereum wallet, right? It's exactly with you. So they also have to verify it's fully authorized. So let's say you hold a wallet and then you sign a transaction, they need to ensure that it's your transaction that you have passed in. And yeah, once a transaction it gets verified, all the nodes get updated about that specific transaction. It's once a block gets added to that specific backlink list, they just publish it and everyone can just get updated with it. So yeah, the final thing, how does a transaction get validated, right? Let's say we understood that we have a linked list, we add blocks to it, and people come to a consensus, they agree that yeah, this transaction is valid, and it gets added. But how does this all happen? So there's two ways to validate a transaction. There's a lot actually, but these are the two standard that we're just going to talk about today. So first one is proof of work, which is used by Bitcoin, and the second one is proof of stake, which is used by Ethereum. So actually Ethereum was also proof of work quite some time back, but yeah, they have switched to proof of stake now. So let's just talk about proof of work, right? So imagine whatever we discussed in the architecture of blockchains, right? Adding transactional data, making sure that it's historically valid, and yeah, verifying the state of chain basically. That all part involves some work from your machine, right? Let's say if you want to calculate 1 million blocks and see if a person is eligible for a specific transaction or not. So that will involve some work from your machine, and that's basically why we call it proof of work. But yeah, it also has, like the blocks we discussed that contains data and hashing, data and the hash of the previous block, right? But they also contain something called nonce, because we discussed that hashing is like just one way route, right? Let's say if I have a data, I hash it, then I cannot like go back to that data from that hash. So what blockchains do to solve it? Because the thing is, if I just, let's say, add a transaction, Shivam adds 500 coins or something like that, and I say that this is the specific hash for that specific data, right? You cannot verify the transaction that I've, like the data basically that I've said there, right? So to verify that, we need something called nonce. So what a nonce does is, like if you just see hash, I've just written as like a random hash for that. But if I just add hash 426, that's basically a nonce number, and if I hash it again, then it adds some certain number of zeros in front of it. So what this blockchain system does is, like, let's say I'm a miner and I want to mine a transaction, then it asks me to find a nonce which will add a certain number of zeros in front of the hash that I've got, right? Like hash is like hashed like that. Then hash 426 will be hashed like that with 10 specific extra zeros in front of it. So when this goes to someone to verify, right, they can use that nonce to verify, okay, if this specific nonce add this certain number of zeros in front, then yeah, this is a correct validation. And yeah, miners compete in this cryptographic competition, right? Like it's quite easy. Like let's say if you have a very good, robust system, you can verify all the transaction is validated and you can add it to the chain. But yeah, just to guess the nonce, it's kind of big competition. Like miners compete with each other, like the one who gets it first, the one who gets to mine the block, and the one who gets to mine the block, they get the reward, right? So yeah, difficulties in this depends on the number of zeros in front of the hash. Like let's say I just had 10 zeros there, right? And currently market collapsed or something like that, and miners are leaving the market. If miners are leaving the market, there's less number of miners in the market to mine a specific transaction. If there's less number of miners in the, say, network, right? At that time, it becomes quite easy to just mine a block, right? Because it's like less number of miners there. So at that time, difficulty just gets increased. But yeah, miners can also join hands to make mining pools. Like let's say if I am a solo miner, then what I could do is like I could just fetch all the transactions from mempool and verify and add it to the network. But the problem would be I have a limited computation power, right? Let's say if we all join hands and we all become a miner together, and then whatever transactions are coming in, we are verifying, and there's higher chance if we have this like whole compute power together to guess that nonce, right? And get the transaction on chain. So yeah, next one is the proof of system, which is on Ethereum. So imagine whatever we talked in proof of work, but what happens in proof of work is everyone is competing for the same transaction. That doesn't happen on proof of stake, right? On proof of stake, you just put certain amount of tokens as as your stake token. Let's say I want to do proof of stake on Ethereum, right? Then I'll stake like 1 or 2 Ethereum. Based on how much stake I have, I'll get a chance to validify a network, validify a transaction. It's not like everyone has to just validify it and the first one who gets it. It's like randomly chosen who is going to verify it. And once, like, yeah, they verify it and add it to network. But yeah, it's completely random, as I said. There's still some risk here. Those are rich getting richer. So basically, let's assume I had 100 Ethereum on 100 ETH on Ethereum to as stake to get to become a validator, right? Then the problem is, since I have a higher number of Ethereum stake, I'll have a higher chance to get a transaction to validify. So if I get a chance to validify a transaction, I get the block reward. I get the block reward, I add it back to my stake pool. I have a higher chance now to get the transaction, right? So this is a challenge that's we are also fixing, like not we actually, but yeah, the whole blockchain space is fixing together. And another challenge is like the no-show validator. Let's say you have someone who is like having 10 or 20 ETH or specific, and they have been chosen, yeah, this is the perfect guy to validify this transaction. And you send the transaction to them and they are like no-show. Like their system is, like let's say their whole validator node is off or something like that, right? That's also one of the challenge. And yeah, 51% attack is something that also is possible in blockchain. So we have talked so many great things about blockchain, but there's some downside as well, which is quite impractical and quite impossible. It's basically like if you can get 51% of people agreeing to you, then you can basically, yeah, still change things on blockchain, right? But yeah, that's quite impossible. And even if that happens, yeah, it's basically consensus of everyone. But how it's a drawback is like, let's say if I'm a very rich person and I have like huge load of systems with me, right? And I have a huge computational power basically. Then I can add fraudulent transactions, so that's basically a 51% attack. And yeah, fraudulence is still not like entertained, it's like punished. Like let's say if you try to add, like when you're proof of stake validator, right? Or maybe even if you're proof of miner validator, when you try to add a fraudulent transaction on blockchain, it's not just that it won't be just added, it will also have a negative remark for you. It's like basically if you have staked your tokens, then tokens will be burned. And let's say if you are running your computation power to guess a transaction and then you're trying to add the fraudulent transaction as well, right? It takes a lot of energy. So it's basically some loss there as well. So yeah, coming back to the same question that we had in the starting, right? What is a blockchain? So we just discussed about set of protocols and encryption, like how it works and how it's like securely added to the distributed ledger. But yeah, there's other aspects to see blockchain as well, right? Like you can say blockchain brings decentralization and power to everyone, right? Like everyone decides what happened on chain. And yeah, it's a distributed ledger technology that powers digital currency, like Ethereum and Polygon, Matic and stuff. And yeah, it's the next generation of Web3. So we'll talk more about this when we talk about the functional use cases of blockchain. But yeah, basically what's Web3 is like on the Web 2, we have just like all the like layers where we can do basically anything but not execute something online, right? Web3 adds that functionality of execution. And yeah, a revolution to bring back ownership to really who own it. Like I don't think so I have it in this slide, but I have in my next talk. I minted my own NFT of graduation. It's like I own it basically, right? So anything that you have on chain can be verified that you really own it. So it adds that stuff as well. So yeah, but an interesting question is how do you read on-chain data, right? Like we talked about the nodes are the ones who read on-chain data and like they can basically get you the whole on-chain data. Let's say you are during this duration of Hackfest building a dApp, let's say a social media platform or something like that, and you want to get all the on-chain data to just show it in your application. So there's two ways to do it. Either you use nodes. So when you use nodes, you get a full copy of chain and you just have to verify it on your own, right? Like as we discussed, like all the transactions, you add it up or maybe you just calculate what you want to show on the UI. Or you can use someone like Morales. So we have our APIs that can help you to get this on-chain data quite easily. And yeah, as IBC partners, like if you guys are building any dApp using Morales or something like that, just drop your connections in the Discord as like questions in the Discord as MC said, right? Like just drop whatever you have. Like if you are building using Morales, let's say a specific endpoint is not working for you, or maybe you want to know how you can get a specific data, like let's say all the NFTs that a user holds, or maybe all the tokens that a user holds, just drop and we'd love to help. So yeah, this was about introduction to blockchain, and I would love to take any questions that anyone has. No questions?
So when you say transactions are verified by everyone,
yep.
does that mean that I have to manually check?
No, you don't have to manually check. You can run basically a program that does it for you. So no, you don't have to write the program. You could just take a program and run it on your node. Like let's say you want to be a miner, right? I was a miner as well 2 years ago. So it's just like you said, you build your own system and you just run a program that does it for you. So it's like you just run the system. That's it. Good question. Anyone else? Do we have any more questions? Okay, perfect. Then yeah, I think this is for the first workshop, and yeah, we'll see you in some time. Thank you. Thank you.
Can we have the lights? But I think we already have the next workshop right now. Thank you, Shivam. That was quite insightful, and I'm sure, frankly, I had a few questions, but I thought I'll ask you separately. Do we have any questions in case we missed it? Anyone has any questions? See, it can be the stupidest, the most stupid question that is possible. I ask a lot of stupid questions just to, make sure even the smallest of doubt that I have in my head gets cleared. And that's how we move forward. We learn from those stupid questions. Otherwise, nobody would ask. All right, so just on that note, we will move on to our next session. All right, once again, any questions? No, perfect. So keep taking notes. If you have any question, even in between, you can ask, you can raise your hand, and we'll provide a mic if the volume is not audible enough. All right, so next we have the next session that Shivam will be taking is on functional use cases of blockchain. In the last decade, blockchain has found its utility in several areas such as finance, logistics, agriculture, insurance, games, sports, and a lot many more are on the way. Blockchain has proven its utility on DEXs, borrowing, lending, derivative products, insurance, which is automatic. Example, suppose there's a drought in a particular area, let's say in India, for example, and with the help of blockchain, once the identification comes in, with the help of blockchain, we can trigger the insurance money to the farmers. So, which is quite an amazing thing if you see in an agrarian society that India is. Furthermore, there are more use cases. As you can see, there are in car purchase, real estate records are all using, people are even buying properties with crypto, all thanks to blockchain. With all of this happening, it is must to discuss this subject in more detail, and Shivam will talk to us more about it. And make sure you ask questions, because this is quite a fascinating subject, and the more you ask, the more we'll be able to help you evaluate it further. Over to you, Shivam.
Thank you. Perfect. Lights off again. Can you just change it? It's not in the same slide. Oh yeah, right here. Perfect. Let's just wait for the slide to show up here. But yeah, as Deepak said, right? Yeah. I was just saying, as Deepak said, ask questions as much as you have, and even if you have questions that you want, you think is very stupid or something, just feel free to ask, because we all are learning here, right? So, yeah, let's just wait for it to show up in a while.
Cable disconnected.
But yeah, we can go back to the previous question, to the previous workshop and the question that we had. So I asked you all to write what is blockchain, right? So anyone voluntarily wants to share what they wrote before the talk and what they feel like after the talk? Anyone? If you want, I can come there and we could just talk right there instead of sharing in front of everyone. So yeah, that's cool as well. Just raise your hand. Okay, so you want to share? Should I get you a mic there or should I come? Up to you. Okay, I'll come. That's cool. Yeah, I'll come. That's cool. That's cool. Yep. So you were blockchain is a decentralized network which is peer-to-peer to transaction and develop the security. Perfect. Yeah, that's exactly what it is. So you had this before the workshop, or you came to this? Yeah. And what do you feel like after the workshop? Perfect. Yep. That makes sense. That makes sense. That's great. And what's your name? So cheers for Chetna. She's the first volunteer to do this, right? So, anyone else? Perfect. Should I jump around again there, or you guys prefer mic?
Excuse me, sir. Here, back of you. Yeah.
Okay.
Yeah.
There, yeah.
So yeah, basically I was having a doubt, like as you said, the transactions will be visible for each and everyone. Then what
Yep.
about the privacy?
So yeah, you can have like transactions which are meant to be public, you can have them public transactions, right? That's basically like you spending your money somewhere. That's basically visible to everyone. Like it's in the database, like anyone can see it in the bank and stuff. But the thing is, you can have privacy as well. Like basically if you create a new random wallet, no one knows it's your wallet.
Okay.
So yeah, those transactions which need to be private, like I assume you're talking about the use cases where we say like you can store medical database records and something like that
Yeah,
on chain,
something
right?
like that.
Yeah, so let's say you're doing something like that, then there's some certain features in smart contracts which allow the data to be read only by the people or maybe the wallet that you agree to. Like let's say Apollo Hospital creates this system where everything is stored on chain, right? Then once they put the data through their system, right, like through the smart contracts on chain, then they can give you the permission, or maybe they can make you someone who could give to someone else a permission to read that data. So the data can be privatized, but yeah, transactions is visible to everyone.
So user will be having that permission to like make it public or private, something
Yeah,
like that.
exactly. It's up to you, whatever you want to do with that.
Okay, thank you so much.
Perfect. Thank you. So yeah, I saw some hands there last time. Yep. So yeah, I'll just move there, baby. Yeah. Yeah. It's just that I didn't had my morning walk, so it's like, make me walk as much as you want, guys. Okay, we are here at the same time, so. So basically, everyone can view your transactions. So what's your name?
I'm Shravani.
Shavani. Yeah, so Shavani asked like if we can know like who can view our transaction, right? So basically, which side? There? Yeah. So basically, anyone can read your transactions on chain. It's like once you have a transaction, it gets, you can go to Etherscan. That's basically a good place to start. You can see all the transactions that happening, how much token has been transferred to some other wallet and stuff. Yeah. Good question. Anyone else? Okay, there. Yeah.
Sir, my question is like,
Just,
can anyone go randomly on Ethereum and can they validate the transactions? Can they? Random persons?
Yeah, anyone actually. But the thing is like when you're doing it, you like yeah, you can anyone can basically to answer your question. But can you give me some more context like what you were thinking?
Like, if a random person just go on and can they validate the transactions or like only some persons it
No, it's open to anyone. Like you could like when Ethereum was on proof of work system, right? At that time I was a miner, so basically I had like 7 or 8 6600 XTs, which were like the graphics card, and they were just mining it for me. So anyone can do it. It's open for everyone.
So we can restrict in the proof of stake, right?
No, you cannot actually. You could just like buy some, let's say if you want to be a proof of stake validator, right, for Ethereum, then you can just buy 10, like whatever amount you want, and you can just take it.
Okay, thank you so
That's
much.
completely decentralized. And that's the power in blockchain, right? Like no one can censor you, no one can stop you. It's like open network for everyone.
Thank you so much.
Perfect. Yeah. Yeah. And your name? Sai Teja. So Sai Teja asked like how are miners going to be rewarded, right? So let's say let's just take an example of Bitcoin, because Bitcoin is currently like the question was like once it's fully mined, right? Ethereum is not like what we call that specific word, but yeah, Ethereum has no hard cap. So Ethereum is like inflatory, like there will be infinite Ethereum, but yeah. Bitcoin is not specific like that, right? There's some number calculated. It's not exactly 21 million Bitcoins is returned somewhere. It's just like calculated based on the halving. Halving is something like, let's say, currently you approve a transaction or maybe you validify a transaction, right? So once your blocks get added to the network, you get some certain numbers of Bitcoins. And that gets halved every certain period of time, right? So your question is like, once it's fully mined, right? Then it's just based on the transaction fee. If that makes sense. Yeah.
Hello, sir. On your right.
Yeah.
Difference between public coin and a private coin, and how exactly private coin works?
Yeah, so What do you mean by the private coin? Like, can you give me
Monero, Zcash.
Yeah, okay. So example with the public blockchains and private blockchains is basically like anything that's on the public blockchain can be seen by anyone, right?
Okay.
It's not exactly anonymized as well. Like, let's say if you have a wallet, I know that you have a wallet and you transact it to someone. Even if I don't know, I could see that this specific wallet has transacted some certain number of coins or certain number of tokens to another wallet, right? You cannot do that on the private blockchains. And that's a concern with the governments as well, right? Because let's say if you have a public blockchain and government can ensure, let's say when there's a friendship between blockchain and the government entities, when government can ensure that, okay, you have a specific wallet and they can basically track all the transactions that you're doing. But if you are on a private blockchain and they cannot track that, then that's a problem for them. But yeah, that's the main difference there.
Then how the validators are going to validate the private coin transactions?
I didn't get you again.
Then like how the validators are going to validate the transaction of a private coin?
Yeah, so transactions are very defined in the same way as I shared, right? Like you have a nonce and you have a hash. They just have to verify this is the correct computation. That's it. Okay. And the computation makes sense when you just add up the total transactions that the previous guy. So I need not to know whom you have transferred your 100 coins. Okay. I just know that if you had 100 coins and you have done 10 transactions that sum up to 99 and you're willing to spend one more, it's cool. But if you're willing to spend two more, it's not cool. So I just need to know how much you have done. I need not to know like where you have done. Okay. If that makes sense. Perfect. Anyone else? Yeah.
I'm asking out of curiosity.
Yeah.
As you have mentioned that there would be reduction of cost of transaction with while we are using blockchain.
Yep.
Is it possible to reduce the cost of transaction? We'll be using Visa cards, credit cards while booking a tickets and for regular use.
Yep.
Is it possible to reduce that cost also?
Yeah, so you're basically asking about the processing fees that you pay with that, right?
Yes, sir.
Yeah, you can basically reduce it to like zero. So there's a project called traveler.com that I use a lot. So let's say whenever you're traveling somewhere else, right, then you can just book hotels or flights with your credit card. But yeah, this is no promotion of them, right? So just don't go buy in the traveler tokens and next day you're like, okay, we bought it, it's dumb, what should we do? So that's no promotion. But yeah, it's a good project there. So it's like I can buy traveler coins and I can pay my hotel bills and maybe flights with that. So if I do that with credit card, that's a big transaction. I specifically have to pay like 2.5 or some 3% of transaction fee and all that. And that gets heavier when you go high, right? So yeah, you could do that with normal public tokens. Like you can use Matic to pay all that and yeah, that can reduce that fee.
Thank you, sir.
Yeah. Anyone else or should we go to the next one? It's like they love when I'm jumping here and there, right? It's like when I was there, no questions. Yeah. Anyone else or we should go to the functional use cases now? Perfect. So I think let's continue. Yeah. Okay, my remote is not working. Can someone please check? Nope. But yeah, I think while they're while they're checking the remote, I think I could just move around and change the slides. So yeah, let's talk about the functional use cases of blockchain, right? So before understanding the use cases, we need to understand what is exactly there. Like we understood how transactions are stored and all that stuff, but what are the spices or ingredients on chain that make sure that, or maybe like that helps us to achieve these functional use cases, right? So there's three amazing things on chain. First one is smart contracts. So this is also something that brought in the Web3 narrative, right? Like, let's say you can store all the transactions on chain and everything, but let's say you can also execute contracts on chain. That will be really cool, right? And when I'm talking about contracts, it's basically just a contract between two parties or something like that. let's say I owe you 10 rupee or something like that. In the traditional world, it's just a contract that I sign. But let's say if I just take that contract on chain, right? It smoothens it a lot. And yeah, then we have tokens and cryptocurrencies. So as we were discussing, there's a lot of use cases with cryptocurrencies. You could like use it to send money abroad. You could use it to pay anywhere. And yeah, tokens and cryptocurrencies are that part. And third one is NFTs, which is kind of very hot at this time, right? Like everyone is talking about NFTs. You'll see a lot of memes. Like it's just a cat picture or a monkey picture. People will claim it, and people will ask you like, what if I just download the JPEG of your NFT? So yeah, there's a lot of stuff going around that as well. We'll discuss in detail. But yeah, these are the three amazing things on chain. So let's first talk about the smart contracts. So need not to remember this because I Googled this as well. So Nick Szabo, a computer scientist and cryptographer, coined this term first in 1997. Like, just don't write it, please, because I used to write this when I used to attend, and it's like literally not worth it. Like, the guy is amazing, but you need not to remember everything. But yeah, smart contracts are basically completely digital contract on a distributed ledger. So let's say you have a contract in a traditional system, right? Then you have a lot of parties which enforce it. Let's say I have a contract to, what should be the best thing? Let's say I have a contract to become a movie actor or something, right? And the director does a fraud on me or something like that. And the contract says that if something like this happens, then they owe me a certain amount of fees or maybe a certain amount of money that they have to pay for my time and all that stuff. But when I have this contract in the regular world, how do I enforce it? I can go to the government, I can go to the police, and it's good, but it's not always the best way to do that things, right? Let's say you all are aware that this contract exists. And then if you all can just help me to get that contract enforced, then it will save a lot of time, right? So that's basically, and it has a lot of use cases. Like, let's just take a simple example, and it's a very real example and very real use case. Let's say you take a life insurance, or it happens a lot in India. Let's say you have a car insurance and bike insurance, and you are 100% sure that you are like entitled to get that insurance amount or something like that, right? Whatever has been signed on the contract. Let's say I had a life insurance of, like, unfortunately someone passing in my family, and now they're passed out, and then I go to claim that life insurance, and there's this a lot of process, and people tend to go to courts and all that stuff. If you can bring this all contract in a public distributed way, like we all can agree that, okay, this contract was there, this contract is now intended to be paid. As he gave the example, Deepak gave the example as well, right? Then it could be really cool. So completely digital contracts on digital ledger. And yeah, it removes the risk of trust. Like, I don't have to trust on any specific vendor, on a specific entity to ensure my contract will be enforced. Like, it is just on the network. Just like transactions get on the network, everyone can like check whether this transaction is valid or not and add it, right? Contracts are also on chain and also on the network. So anyone can see a contract, and once they know that this contract is entitled to be, like, let's say executed, it will get executed. So it just removes the risk of trust and maybe like dependency on a other entity. And yeah, smart contracts are like mini executables on chain. It's like, let's say I have a very simple smart contract, like India-New Zealand series is going on, right? Who watches cricket here? Can you just raise hand? Yeah, so let's just say like India and New Zealand cricket match is going on, and I'm having a contract with my friend that if Hardik Pandya scores like more than 20 runs in a specific over, then he should be giving me 500 rupees or something like that, right? If I have it in the, let's say inwards, then he's definitely not going to pay me. I'm 100% sure. But if I have this, let's say as a legal contract or something, and if it doesn't pay me, I need to go to like police or something like to enforce it, that I have a 500 rupee legal contract that doesn't work in real world, but just assume it like that. But if I have it on chain, it's like just he agreeing to this specific contract which says that, okay, if this certain thing happens, he used to pay me. We will probably need oracles in this, and I'm quite sure we have a talk on oracles tomorrow, which could give you a brief more about what they are. But basically, in the simple terms, they are the ones who could bring off-world data on chain, right? Like, let's say Hardik Pandya scores more than 20 runs, but how a blockchain knows about it? Someone has to feed that data in, right? So those are basically oracles. So let's say using oracle, we had we had a bet, like if Hardik Pandya scores more than this, then I get 500. So when you have this in contract and Oracle reports this data, right, then everyone on network know that, okay, the smart contracts conditions are met, so they are basically like good to execute, and that gets executed. So those are like mini executables. And yeah, contracts are immutable and decentralized. It's like once you sign a contract, it just cannot be changed. It's not like, okay, you signed a contract to get a, like basically you didn't sign a contract, but let's say you got admission into like a computer science degree and then you are graduating as a doctor. It's just not possible there, right? So contracts are immutable and they're with everyone when they're decentralized. So it's not like a dependency that we talked about. And yeah, network enforces the contract. So everyone who is participant of the network, they make sure that whatever contract states or whatever conditions are there in the smart contracts, once they are met, they are enforced. So networks enforces that. And yeah, let's talk about the next cool thing, which is tokens and cryptocurrencies. So this is very cool thing as well and devastating as well if you go 100x leverage on some certain pairs. But yeah, let's just talk about what are native tokens or coins. So we talked about rewards, right? Like some of you asked questions as well, like what if like, let's say all the coins are mined and stuff. But basically how these rewards are given are in the certain native tokens of a chain. Like if you're talking about Bitcoin, right? Very simple example. Let's say I transacted my Bitcoin to someone else. I sent some Bitcoins to you guys. I don't have much, but let's just assume I sent some Bitcoins to you guys. And that transaction gets approved and validated by a specific miner. So they get rewards in Bitcoin. So those are like the native tokens or the native currencies that we call. And that acts as an infra, you know, like you cannot build, like you can build on top of Bitcoin, but yeah, Bitcoin maxis don't like it. But yeah, if you talk about Ethereum, right, like that acts as an infra to build the dApps. So you can make a coin on Ethereum. You can make your own specific ERC20 or let's say any standard that you like, coin on top of Ethereum. And yeah, just to make sure, like ERC20 is nothing, it's just a standard way of writing things that we all agree. Like let's say when you make your coin, then you need to add some certain features, right? Like let's say how many coins exist in the market at that time when you mint it. Or maybe like who holds the right to transfer these coins and all the things that you write around it. So that standard is just ERC20. But yeah, you can make, basically they are infra and build apps top of it. And yeah, you can make your own coins on top of it as well. And these native coins are fungible. So it's like if I have a Bitcoin and if you have a Bitcoin, right, there's no difference. It's just the same thing. They are not like non-fungible like NFTs. And we'll talk about it in the next one as well. But yeah, they're fungible. So let's talk about the other tokens which I discussed, like the ones that you built on top, right? Let's say you are in Ethereum ecosystem, like you are like an ETH maxi, and we all have that, right? Like how many of you are like iPhone maxis here, like who like iPhone? No one? Everyone uses Android here? Don't tell me. Yeah, okay, so we have some iPhone maxis here, but yeah. So let's say if you want to do, like let's just take the main example. Let's say you are on Ethereum and you are ETH maxi and you want to trade Bitcoins, right? Then you can make your own tokens and you can use that specific feature to create something like wrap BTC which exists. Like you can buy Bitcoin on the Ethereum network, and then you can also make other tokens, like you know ApeCoin, right? That got quite a lot hype on Twitter. But yeah, you can make these type of your own currencies which could be used for specific thing. Let's say like, IBC is doing a great job to make this free, but let's say I hold my private workshop somewhere and I'm like charging something, right? And I don't want to use the traditional fiat system. Could be for several reasons, right? Like let's say I want to hold crypto or some reason. So I can use my own tokens, or maybe I could use, like the best way here would be to just use any native tokens that exist. But yeah, let's say if there's a use case that I want to do that, I can do that as well. And let's say I give special classes to my token holders. So this will help me in some other benefits. It's basically like a stake that you have in a startup. But yeah, these are also fungible, right? So whatever random token I make, if that's with you as well, that's the same thing that we both hold. But yeah, let's talk about the non-fungible part. This is like the most coolest part, right? Like tokens, the same way that we discussed in the previous slide, right? Like you can make any random token. NFTs are kind of same, but they are non-fungible. Let's say I hold a NFT and you hold a similar looking picture as an NFT. It doesn't mean that we both hold the same thing. like my NFT could have some different metadata. Let's say even we both have same metadata, the contract of that specific NFT would be different. And that's why they are non-fungible. And yeah, NFTs bring in ownership of an asset. Like I'll show you in the next slide, probably. I think it's like 3 or 4 slides more. But basically, I think, yeah, it's 3 or 4 slides more. But let's say you get your graduation degree or something like that, right? I tried this basically, and it's illegal, just to let you know, but I got my graduation degree, and I just for fun activity, I just printed the similar. I changed my scores, exact same print, exact same paper, and I used that to apply in a random company. It's illegal. They could go and check it, but basically, it's some process there, right? That has to be done to do that. Let's say you hold that as an NFT that has been given by your university. It takes like less than 2 seconds to go and verify it's your own degree or not. And also you own it, like you really own it, right? Like let's say you clicked my picture and you made an NFT out of it, right? So if you make basically, yeah, NFTs are something that gives you the ownership, just to give you the broad overview. There's a lot of use case as well, which we could discuss later. I have some more slides there. But yeah, it's also not splittable. Like if you have a coin that's splittable, right? Like you need not to do transaction of 1 BTC every time. That's like $15,000 now or something. That's very low, but yeah, that's expensive, right? You cannot just do a transaction of a whole Bitcoin. So you can split the coins and you can do transactions with the minimum of those. And the minimum in Bitcoin is called Satoshi. But yeah, NFTs are not like that. You cannot split an NFT. And yeah, is unique as well. Like every ETH is same, every BT is same as we discussed. It's not the case with all the NFTs. NFTs are unique. Let's say you make a ticket, right, for a specific event to get in. Like let's say instead of you all registering at the desk, you could have all just minted a NFT which would have allowed you to get in. So those are all unique. Like they may look like, all tickets may look like same, but they all are unique. And that can be used in a way, like let's say, if they're all unique, you could just have a QR code or scanner, just scan it and mark your attendance through that or something like that. And yeah, for NFTs as well, those NFT contracts are immutable and decentralized. So once you have minted an NFT, you cannot go back and change that same NFT. But yeah, question, what should we do with all of this? Like we have smart contracts, tokens, and NFTs, what should we do? Like if you just Google, right, functional use cases of blockchain or something like that, I tried it. There's a lot of stuff that comes in, like you can do finance, you could do tracking and all that stuff. But that gets kind of boring. So I wanted to simplify it, like what you could do with this. And let's start with your birth, right? Let's take it from the childhood to your death. Like that's sad, but yeah, let's take it from the start till the end. So let's say when you are birth, right? Let's say and you want to register your birth certificate. You need to go to your nearest district office or something that we call. I'm not sure, my parents did it for me, but yeah, your birth certificate can live on chain as well. Like if I have to share my birth certificate as a proof of existence or something, right? I need to hold that paper, I need to show that and all that. But if it lives on chain, it solves a lot of problems. Like this can also be done with your driving licenses. Like let's say if you're not carrying your license or something like that, but you have a license, then basically it's not logical to charge you there for not carrying a driving license, right? Like when you get through a traffic police, they ask you, show me your driving license and all that. Now they're doing it digital as well, which is great. But yeah, again, the digital contracts, the digital licenses or pictures can be forged, right? I can just make a Photoshop of my driving license and just show it to the traffic police guy at that time. He cannot do much. And for a country like us, right, it cannot be like every time when you show something like that, they have to verify. They can still make a QR code and like make a system which could work in the similar way. But yeah, having it on chain can give easy access. And you can also have role-based access control, right? I think the guy from there, someone asked like, yeah. So he asked like, what if we have like if you put your birth certificate on chain, that's not much of a problem. But let's say if I have some degrees which I don't want to share, and my hospital just puts it on chain, so that's not cool, right? But yeah, you can have something called role-based access control. So only the wallets, or maybe only the people, I call wallets people here, the only people who are allowed to see that, they could see that, right? So this is also a smart contract application. And the thing is, this can be done really quick. Like if you see the traditional birth registration process, it takes like 7 to 15 days. It's like you take your baby, which is moving like this in all the office. You don't take your baby, but yeah, just imagine baby moving like this in the office and doing all the registrations. That's how long it takes. But yeah, on blockchain, it could be just done in like a minute or two. Let's say like you went to some certain hospital and you like maybe your parents and you got birth there. So your hospital could just take your data from there and they could just do it on your behalf and add you as one of the owner, or maybe the in the role-based access control model, right? Like maybe just add you, the one who also owns this. And yeah, data reliability can be ensured. Like we know a lot of fraud is done in India with birth certificates. Like people try to keep their age low. Let's say I was born in 2000 and I say that I was born in 2005. So I am like much younger. I am eligible for some state level cricket. I love cricket. So yeah, that's done a lot. So data reliability can be ensured in the specific model. Like whatever hospitals are adding, that can be verified, right? And then we have fraudulence can be reduced, yeah, which is basically the same thing. And yeah, you can get educated on NFT. So on chain basically, yeah, this is application of smart contract, of NFTs and tokens at all, right? Like imagine you joining in kindergarten or school or high school and university or whatever on chain. So instead of you have to show up all your 12th mark sheets and all your 10th mark sheets and everything, and then they're doing a formal registration, you could just like, basically education can be simplified, right? Like IBC is doing here now. Like I don't know who you are, I don't know your KYC or anything. You are here and we are just learning together and discussing together. So it could be basically simplified that way. And it's also an example with metaverse, right? Like you have heard about a lot of metaverse. People are making like crazy kinds of metaverse. Like you can talk to random people on the stuff, but it can be used in the best way as well, right? Let's say we all cannot come to here every day, right? But we make a metaverse where we all gather and we just talk around for a specific subject or something like that. So yeah, you can basically get educated on chain, and you can also share your progress on chain. This is really, really important, because when you apply for a job, right, then you just write like you have done a lot of projects and everything, and you just link your GitHub profiles and everything there, right? But you can literally share your progress as you're going with NFTs and like make it more reliable, right? Like let's say if I say that I have made a project which is like a AI project to identify anything that's generalized. So if I run it from here, I can see bottles, I can see chairs, I can see people. But what happens in the traditional world is you make that project, you put it on GitHub, you just put it there. And maybe if you just download someone else's GitHub repo and just put it there, it's the same thing. But let's say you are making it under a specific professor or under a specific research or something like that, right? Whatever progress you are getting in, you can basically draft that as an NFT, and that will be something really cool that you could show to a recruiter, right? Like let's say your faculty, which has authority to say that, like basically once you get graduated from your college, they have authority to say that you're graduated. Just like that, your research professor or faculty has authority to say that you have done some certain work, right? Then he can share all the progress that you are making while you are doing that project. And that can be shared in a much better way as NFTs. Like you could just have an NFT for running a basic model to identify bottles first, and then maybe you improve that model with some more data. You add all this progress as an NFT. So that will be really cool. And yeah, you can have ID cards as your NFT. This is something really, really important for me, because I think if I have to recall, my attendance percentage in my college was just around barely 76, 77. 75 was how much it was required, and I had 75, 76. And it was not that I was not interested to go. It was like most of the time I used to forget my identity card. It's like on the gate, the gatekeeper is like, okay, you don't have identity card, you don't go in. I show him photo, he's like, no, you need to get that real one in. So you can maybe have your identity cards as NFTs, and this will also ease in the student access programs, right? Like if you see GitHub's program for student package or something like that, for that you have to apply with your education mail, and once you approve it, you get it. But the thing is, I'm graduated, I still have access to my education mail. I can still use that, right? But in NFTs, you can basically set metadata, and like on the organizational level, you can check whether a real student is, like a student is still a real student or not. And you can do that all this with your like ID cards being showed as NFTs, right? And yeah, this will be smooth for entities to manage students. Like they don't have to, let's say you go to library and then you have to like basically show your identity card, they track all the numbers. Instead of that, you could just show your NFT, they could just scan it, and everything that you borrow from library, that's stored on chain. So it's not like I showed my ID card, I took a book, and then after 10 days, I'm like, okay, I didn't took a book. So they're going back the CCTV. But yeah, these all things can be eased in while you are managing a system. And you can share your achievements on chain, right? Something like this. So I got graduated recently, I minted that as an NFT and I shared it on my Instagram. So it's like, this can verify, like basically this cannot verify anything because it's just an NFT minted by me. But let's say my college does this instead of me, right? Like I didn't click the proper snapshot, but if you click the digital collectible, it shows which wallet has minted it and it shows all the metadata around it. So my metadata basically could have something like, let's say my CGPA 8.58 and yeah, something like that, my registration number and stuff. So those could be those could be some things that could be in my metadata. And let's say if my university shares this, right? Then I could share this with an authenticity that I own this. Or else, like, let's say I want to make another graduation certificate, but I add MIT or Harvard something on top of it. I can just Photoshop. Like you see on LinkedIn, right? People just add like their CEO of some certain companies. Like anyone can add anything on LinkedIn. There's no verifiability. But if you share your achievements or maybe like your identity cards and stuff as NFTs, right? It could be easier for those platforms to manage it there as well. Let's take the next use case, which is metaverse, right? So this has like joint application of all the things as well, like smart contracts, NFTs, and tokens. So yeah, as we discussed, you could join universities in metaverse, you can meet people and make friends in metaverse. And yeah, any online world simulation can be brought into metaverse, but the good thing is you can add ownership there. It's like, if I'm delivering this talk here, right, and let's say I own it because I'm giving the talk, but let's say if someone records a video, right? It basically is just a copy that they have, right? But let's say on a metaverse, you all get a recording. Then you could basically say that you own it. And this solves a lot of problems. Let's just take a very simple example of Netflix. Like you all have Netflix. I'm sure you guys are good enough. If I ask your password, you'll share it. But those certain accesses can be improved with NFTs. Let's say instead of having a password or something like that, instead of having a password or something like that to access Netflix, you can make a kind of metaverse like you see in the Facebook Oculus Rift. Like you can watch movies and everything in that VR. But yeah, it's not that metaverse is just in VR. It could be on your system as well. It's still, we all are deciding what it is. But let's say Netflix is like a metaverse. So instead of having that password-based access, if I have NFT-based access, right, then basically I cannot share my account with everyone. It's like if I have to share my NFT to you, basically it's like you take it and then you're gone. If you take the password and you're gone, I can recover it with email. But if you take my NFT and you're gone, then I just can't gain back access to my Netflix or something like that, right? So this will solve problem at their level. Like Netflix will have much more better management with this. And let's take example on your end. Let's say you own an NFT to watch a specific movie. So it's like I recently watched Black Adam, really nice movie. Usually how people share it is like they just click a picture of them in the theater and all that, and that's illegal as well. But let's say I own that as an NFT, as an experience, like that I enjoyed that movie or something like that. It could be a better way to share that as well. And there's a lot of other use cases as well. And yeah, you can access on-demand streaming theatrical experience as we discussed about the Netflix use case. And you can also access, let's say, chain smokers are doing a new show somewhere, right? Like instead of you going in the crowd completely sweaty, you could just have an NFT and show it to your friends, basically, right? That's the thing, because we go to concert to enjoy it live, and we go to there to share, right? Like if you see any DJ in India, when they come, you'll see everyone holding their phones because they want to share about it. But yeah, there can be a better way about sharing with NFTs and stuff in there. And yeah, you can run an open community or maybe an open entity, which is a DAO, a decentralized autonomous organization. So where decisions are made with everyone's consensus, right? Let's make a DAO right here. So if we are a DAO, if you guys if we all agree that I need to go on the next slide, I'll go on the next slide. But yeah, this is a very simple example. But how entities can run is, let's take an example of Apple. They removed the, what was that? 3.5 mm jack in, I think, iPhone 7, right? So they are a company. They could basically just do anything as they want about it, right? But let's say when you run an entity as a DAO, then you basically take in input of everyone, basically whoever is participant of your DAO, and you run it that way. I would love, I'm not exactly sure, I might have to check with Deepak later, but I would love if IBC also would run the programs as DAOs. Like, you decide what's going to happen next, like what you want to listen, what you want to do. And that is a power that can come with a DAO, right? Any member can propose anything. If a consensus agrees on that, you can do that. So that's really cool. And yeah, these were the basic use cases that you have with blockchain. With blockchain. And let's get back to some questions if you guys have. Assume any random use case that you have in your brain and you want to know like how that could come on blockchain, and we can discuss that. Anyone? Or should I have to jump around again? Yeah, I heard yes. That's not cool. But yeah, that's cool. So we have any questions? Or maybe we can discuss what you will be making here, like in the Hackfest duration. Like what use case you are trying to solve. Okay, looks like we don't have any questions. Okay, you do? Great. Yeah. Yeah. Yep. 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 So her question is, let's say like we have role-based access, like who can read from a smart contract and who can write, then how is that still public, right? So that's the transactions as we discussed, right? Those are public, but smart contracts are basically a contract between two entities, and that's how you want it to be, right? Like contracts should not be able to be read by anyone, but let's say if you wanted to share with anyone, you could do it at anyone, right? So that's how it is meant to be, if that makes sense. Didn't get you? Yeah, it doesn't give the ability to control over it. But let's say I make like the most traditional functional use case, right? Which is, let's say I have a health insurance or something like that as a smart contract, right? Then you don't want it to be very public, right? Let's say you have a 2 crore health insurance, you don't want to share it. But if you want, you can share it and anyone can read it. But it will have role-based access based on who can withdraw the funds from that specific contracts, right? Let's say the whole network agrees that, yeah, your health insurance is completely valid and you should be able to claim that certain amount of money from there, right? But if smart contract makes it open, like anyone can withdraw it, which has happened with some projects actually, they didn't have proper role-based access there based on specific wallets, so anyone could come and withdraw it. That's basically like a hack, right? Like it's like money on the table, anyone can pick it and go. So yeah, that's what you could add there. Like you could add like, okay, this contract states that you, like maybe like I am the health insurance, so I owe to pay you 1 crore rupees or something like that as health insurance. Anyone can read it, but not anyone can execute it. Like they can all agree that, yeah, this contract needs to be like enforced, and it will be enforced, but they cannot execute the withdrawal of that. That could be done with role-based action. So with role-based, I meant that. If that makes clear. Perfect. Anyone else? So I think we're good. Okay, we have one in the last, yeah. Yes, please.
Can you to come here?
Yep. Yep. So what's your name? Okay, perfect. So Sandeep asked that he saw a recent YouTube video where they have built their own mining rig, and what's exactly a mining rig, right? So as we discussed in the first introduction to blockchain talk, when you want to verify a specific transaction, you need to do some computation, right? So mining rig is basically like a computational system that you use for specific operation. Let's say like, which one did you see? Did you see ASIC or did you see like a normal one? Like they were using CPUs? Ethereum mining, yeah, perfect, perfect. So they were using, he shares that they were using a normal computer system. It's like basically a system with a lot of graphics card and stuff. And that was for the Ethereum miner because, so they did two types of mining rigs as well that could exist. So you could have something like this, which is a general computational system, and it can be used to mine for a specific algorithm, right? Let's say if I have a 7 GPU rig or something like that, I can use it to mine ETH hash, or I can use it to mine a specific another algorithm as well. And there also exists something called ASIC miners, which are for specifically built just for mining. So if you have your general computational system, right, if I have 7, 8 graphics, or as he said, right, the mining rigs, I can use it for any purpose, but it's just like they are using it for mining the coins, right? They're not actually directly using it to mining the coins, they're using it to validify the transaction, and the reward of that is that they get a coin, right? So they're basically using that system to do that, but it can be used for anything. But yeah, if you want to know more about mining, you should probably read more about ASIC miners as well, because those are made just for that specific operation. Like if you buy a ASIC miner to mine SHA-256 algorithm, which is Bitcoin, right? Which is to validify any transactions on Bitcoin. So that will work just specifically for that. But yeah, I'm not so sure how much legal it is here. Yeah. Anyone else? Check, check. Still awake?
Sir,
Yep, there. Yes, please.
sir, how many validations should a transaction have so that the transaction should occur? Like how
Yeah,
many validations?
that's a great question. So, what's your name?
Hanisha.
Yeah, so Hanisha asked, like, how many validations do we need for a transaction to be validated, right? So this depends completely on the network. Like, let's say, as I recall, I think I've done recently some transactions on Tron. I don't really check that, but it's like, I think 20 or something that you need in Tron transactions. But yeah, that depends on different network. You can have your own specific chain where you could say that, okay, I'll need at least 500 people or 500 validators to like verify whether this transaction is good or not. Because let's say I am a miner, right? I add the block, and then everyone has to verify whether that's correct or not. So that's what you asked, right? That depends on the network, and you can have, like, let's say if you make your own blockchain, then you could just have it as much as you want. But yeah, that varies, and that's just on the choice of them. Like it's like the more validators you have, the more safe it is, you could say, right? Like if you have, let's say 120 validators, then like once a transaction is like in the mempool and it's approved that yeah, it's good to be added, 121 people see that, okay, yeah, this is correct, we should add that, and then it gets added. So yeah, you can have it, but yeah, it depends. Like if you have more number of validators, the problem will be it will make the network slow as well, right? So that's like a sweet spot that chains figure out on themselves.
How much is it for Bitcoin and Ether?
Yeah, I'm not exactly sure how much it is for Bitcoin. You could just Google it, like how many validations are required for a specific transaction. That should help. But yeah, anyone else? Yep. Let me just. Yep. Yeah, no? Yeah, that's cool. Yep. Yep.
Guys, I'm taking a pic from the sit straight. Yeah. See front.
Yeah. Yeah, so what's your name? Vaishnavi. Yeah, so Vaishnavi asked, like, let's say currently all the transactions happen through banks, and if everyone starts using blockchain, then banks will run out of the business, right? That's kind of true, because that happens. Like, let's say if you talk about the pull carts, right? Like the horses one. So when cars came in existence, like their job got out. But it's exactly not that. I don't want to comment much on that. But it's like it will happen for good, and there'll be still jobs for them. And let's say like they are the one who are handling how much you are staking somewhere and all that. So yeah, there's still use cases of that a lot. Exactly, it will create a lot of new job opportunities. It's just it will kill the lame ones. It's basically, I'm not exactly sure who it was, but I was seeing a tech entrepreneur's interview. I think it was Vitalik Buterin, but I'm not exactly sure. So he was asked like, no, I don't think so. It was Vitalik Buterin, but yeah, whoever it was, he was asked like, what do you think about technology? Like, if we advance more in technologies, it kills a lot of people's job, and do you think it's wise because many people will be unemployed and stuff? So they share that it kills the lame jobs and it creates the good job. It's not like there'll be a case where AI will rule the world and no one has to do anything. There will be no point like that. So yeah, it will kill the lame jobs, but yeah, it will create the good, better ones. Yeah, yeah. Yeah, that's a good question. Your name? Yeah, so Nikita asked like, how does this virtual concerts and teaching and stuff can be happen on the metaverse, right? Let's say currently, let's take a very simple example. You want to be a teacher online, then what are the ways? Like, you could obviously start your own YouTube channel, right? And then probably once you have quite a good audience, like in India, we have Physics Wala, right? Like you all are aware about that. He has a great audience. He teaches great. He's a great person. And once he had his good audience, he created very low price courses that people can access as well, right? Either it's just that way, or maybe you could do the similar thing, but instead of doing it on the Web 2, you do it on Web 3. And I'll just share what are the benefits that will be there. You just don't do it because it sounds cool, right? You do it because there should be some benefits. Let's say you purchase a specific course or something like that in your Web 2 traditional ecosystem. Contract simply to do that, right? Instead of having a traditional system which takes like, if you have gone through the refund process, it takes like 2 to 3 days in most of the systems and all that. So you can avoid this specific thing. You can do a lot of other stuff as well. Let's say like your student gets, like we talked about the progress NFTs, right? Let's say whatever your student learns, they get as an NFT that they could share. So that's a better way to share, right? And that's a better way to verify. Like you just mint it from your wallet. Everyone knows that, your name again? Yeah, everyone knows that Nikita is the best teacher here. So they know that, okay, if Nikita approves something, they need to trust on it, right? So that could be a better way to do it apart from the certificates as well. And there are other stuff as well that you could probably do. There's like a lot of stuff. Yep. Yeah, that's a good question again. So she asked like, let's say if we talk about the concert, not the teaching. So when I say that, I gave the example of like a chain smoker concert, right? And they are performing. And she asked like whether it will be a real one or it will be virtual. So that depends. It's up to them. Let's say it's a recorded show that you're watching, right? It could be recorded. If you want, they could do live as well. But the cool thing will be, let's say they do a live concert on YouTube, right? Or let's say they do a live concert or on a specific platform, right? It's paid and it has a paywall and everything to make sure they get money for their hard work as well. But yeah, let's say they do it that way, it could still be like stolen. That could be done in the NFTs ways as well. Like you could just ask your friend, come sit and enjoy the show with me. But yeah, basically the thing is like when they do it on chain, it's basically like everyone can get a thing to show off, right? Basically, we like that as humans, right? We go to a movie, first thing that we do is click a picture. We land somewhere from the airport, the first thing we do is click a picture and show. It's better if you do that with NFTs because like I could just, if you just maybe follow my Instagram or something like that, I could just post a picture right now sharing that, okay, landed at Hyderabad, 10 minutes after landed at Delhi and then 10, it is completely possible. But if I share it with NFTs, that brings more value to it, right? There's a lot of other valuable use cases with NFTs as well, which we discussed, right? Like, let's just talk about the ID cards and all the stuff that we already saw actually, like how you could have the real value thing. But yeah, even this entertainment industry is also the value. So yeah, that's basically the answer. Like yeah, it can be recorded, it can be live, but yeah, it adds fun to it. Anyone else? Check. So we are good, I think. Perfect, then yeah, thank you for listening, and I'll see you around. Yeah, thank you.
Yeah, that was fantastic. So, yeah, thank you, Shivam, once again. And students, that was quite fun. So, as you can see for yourselves, it's always good to, keep talking. So, before we move on, we'll take a quick break, but a break where we are not going to go out, we'll just stay inside. And before we take that break, I'll be doing one or two things, just to warm up for the next session. And before that, what I want to do is basically I would request my tech team to, put the presentation back on the screen. So I can just give you all a walkthrough on our Hack 2, IBC Media Hack 2, so that you all have an idea where to go, where to register, and where to participate in our hackathons. The prize pool is massive, so you should definitely check it out. I think I can close this now. Yeah. So you can use the same process. It's quite simple. Obviously, we'll be sharing these links with you at the end of the day. Oh, guys, can we have the laptop screen, please? Yeah, thank you. So I'll just, if you're doing it right now, here's a basic Google search, IBC Media Medium. You go to the first link, and here we are. We have IBC Hackathon platform registration / onboarding process. So you can check it out over there. I'll just give a glimpse of what we are talking about here. This is basically a step-by-step guide on how to register for the hackathon. You will find the prize pools over there and different hackathon tracks. So if you see, you have, firstly, you have to register by signing up. Then you apply to participate in the hackathon, where you get the options to choose the track, and then obviously submit your interest by creating an idea on the platform itself. So what we generally do is, if you have an idea with you, that is great. But if you don't, you can still register and form a team, speak to your peers, and scrutinize some new ideas and figure it out. And then maybe you can come back and carry on your registration and submit your idea then. So you can register right away. If you don't have an idea, you can come back later, and then you can submit your idea by creating a team. You can also be an individual. It's all open for you. So after the idea, along with the idea submission, you have to obviously upload the relevant document of your idea, through which IBC team and the experts that we have will know what exactly you are trying to build, and we will evaluate it accordingly. And then once it's done, you submit, and that's it. Here's a screenshot of the process. This is basically our website. As you can see here, you go and you can choose the, right now I would suggest you to go to IBC Hack 2 because it's live. IBC Hack 1 has closed. Yeah, so I won't take a lot of time because it's just the same bunch of screenshots. It's a very simple process, and I'm sure it's not going to be a problem for you all. All right, so we are up for a break, and the break is going to be starting by, I would request all the students on the back side to come up front, and we are going to make the next sessions even more interesting. So let's do one thing. Can we all stand up for a second? Wow, I know it has been tiring. I know it has been exhausting, but it's fun. Trust me, it's fun when you have a speaker like Shivam handling queries and constantly communicating. So one small request, the last two rows can, maybe on the left side, the last two rows can come up front, last 2 or 3 rows. So it's easy to see you all and talk to you what you're doing. So let's not be the last backbenchers here. Come on. Same goes for the people on the right. So nobody is going to sit until you guys come forward. So let's do it. Come on. Quickly. In the front, I see 1, 2, 3, 4, 5, 6 rows. So all of you, come on, move forward. Let's do it in next 45 seconds starting now. And the people who don't have to move, you can count 45 seconds until then. Okay, by the speed of it, I think it's going to take a little bit more time. Come on, guys, let's do it faster. Okay, I see movement already. That's nice. Come to the front seat. We'll have some fun. No serious questions here. Yes, thank you, sir. Guys, come on, come up front. Yeah, same goes to the people on the right. Okay, I think we can do this for another 30 seconds and then we'll. Okay, great. So here's what we are going to do. We are going to stand up for a second. All those who have sat down, please get up once again. It'll just take 3 seconds. Rub your arms, just freshen up. Yeah, it's like in school we do. I'm sure all of us have done. So rub it as good as possible and then freshen up your face. So you are ready, and obviously we'll start in a couple of minutes. Yeah. And we can sit back again, and let's again give a huge round of applause to Shivam for an extremely super session. I'll be back in 2 minutes, and then we'll begin our next session. Thank you. You are not leaving, you're going for the toilet break.
Internet of Things. It is the most important innovation that is happening around us. What is Internet of Things? Taking anything that's not connected to the internet and connecting back to the internet for efficient use to ease people's life. It has the ability to make our environment smart. This provides the opportunity to the smart lives. IoT is going to be one of the biggest agents of change. We at Nitro aim to drive place. It all starts with you. A smart world where we live conscious lives, efficient lives, productive lives. We live life in a smart way. And we believe that IoT is going to be one of the biggest catalysts that makes us and everything around us smart. Right from your home to large infrastructure and everything in between. Come join us to make our world smart. Internet of Things. It is the most important innovation that is happening around us. What is Internet of Things? Taking anything that's not connected to the internet and connecting back to the internet for efficient use to ease people's life. It has the ability to make our environment smart. This provides the opportunity to the smart lives. IoT is going to be one of the biggest agents of change. We at Nitro aim to drive mass adoption of IoT. We want to make the world a smarter place. It all starts with you. A smart world where we live conscious lives, efficient lives, productive lives. We live life in a smart way. And we believe that IoT is going to be one of the biggest catalysts that makes us and everything around us smart. Right from your home to large infrastructure and everything in between. Come join us to make our world smart. Internet of Things. It is the most important innovation that is happening around us. What is Internet of Things? Taking anything that's not connected to the internet and connecting back to the internet for efficient use to ease people's life. It has the ability to make our environment smart. This provides the opportunity to the smart lives. IoT is going to be one of the biggest agents of change. We at Nitro aim to drive mass adoption of IoT. We want to make the world a smarter place. It all starts with you. A smart world where we live conscious lives, efficient lives, productive lives. We live life in a smart way. And we believe that IoT is going to be one of the biggest catalysts that makes us and everything around us smart. Right from your home to large infrastructure and everything in between. Come join us to make our world smart.
We can begin. Guys, if we can pause the video, we'd really appreciate it. Thank you so much. I hope everyone is here. Just check around. Why do I see a few? Okay, students have come forward. This row is empty. Are more people outside? Yeah? I would request our IBC team, volunteers, to just check if anybody is outside and ask them to come in so we can begin. So a lot of students are giving some video bites to IBC media. So that was what was taking time. I think we'll be beginning in another 1 minute.
Hello everyone, my name is
Okay, I guess Shivam will be joining in a minute, but actually wanted to ask him about his Bitcoin. He was referring he has a few Bitcoins. I just wanted to know how much he has. So I'll wait once he joins. I have some trickery to play with him right now in my head. I guess he'll be here in 30 seconds. Never mind, respecting the time limit, what I'll do is we can start with the next session, which will be an online virtual recording that will be seeing, and question and answers will be taken by Shivam. So make sure you note down your questions, and we will take it all up after the session is over. So now we will be talking about layer 1 versus layer 2 in blockchain cases scenarios. So layer 1 basically is the foundational blockchain. You have examples of Bitcoin, Avalanche, Ethereum, Solana, and many more. Even Polka has gone further to say that it's a layer 0 chain. Why did we come from L1? Guys, I'm seeing of some sound. Let's settle in so we can, just get on with the session. So why did we come from layer 1 to layer 2? In Ethereum, there were too many applications that made, so Ethereum is basically the second most important name that you will hear after Bitcoin, right? So Ethereum, in the initial stage, there were too many applications that made scalability a challenge, which is why transaction fee was extremely high. And people had to pay a lot for a single transaction, and when they would end up doing, for example, 1,000 transactions, then they would have to make the same transaction, pay the same transaction fee for 1,000 times. So obviously that's quite costly. In layer 2, they use the same security mechanism of layer 1, but they handle the transaction in a side chain. On layer 1, we have to pay, like for example, on layer 1, we have to pay for each transaction. On a side chain, you go and all those transactions are done, and then the entire transaction goes back to L1, and then it is considered as only one transaction, so that saves a lot of money. But don't take I think it's a recording, but we have with us Mr. Spencer White, who is part of the research and events team at Moralis, and he is also the CEO and founder at Acrometa Solutions, a Web3 R&D collective. Requesting my tech team to just put the video.
Hello everyone, my name is Spencer White, and I work with the Moralis research and events team. Today, I have prepared a presentation on blockchain layers. This presentation defines what a layer 1 protocol and a layer 2 protocol are, what the difference between them is, and also several potential use cases for various different layers of blockchain technology. To start, it is very important to consider the blockchain trilemma. The blockchain trilemma is a term coined by Vitalik Buterin to describe the 3 biggest considerations for blockchain development. In essence, what it means is, when building a new blockchain, you have to pick between 2 of the 3 ideas on the blockchain trilemma. Basically, you cannot be secure, scalable, and decentralized all at the same time. For example, Ethereum is highly secure and decentralized, but it lacks the scalability it needs. Whereas something like Binance Smart Chain would be secure and scalable, but it is not decentralized. This is an important consideration considering that the concept of blockchain layers was originally devised as possible solutions to the blockchain trilemma, the main one being scalability. When thinking of layers, the main way to think about them is, depending on the number of the layer, it represents how many steps away the transactions are from actually being executed. For example, the layer 1 protocol, which we are all most familiar with, is the protocol where the execution actually occurs, meaning the transaction is finalized in its completeness. A layer 2 protocol, for example, would be the layer that computes the transactions and then bundles them before appending them to the mainnet protocol which they are computing for. Basically what this means is a layer 2 protocol is taking transactions off-chain, bundling them, reducing their transaction size, and adding them to the main chain later. Another interesting thing to think about would be a layer 0 protocol, which this phrase is loosely used, but what it represents is an underlying infrastructure for interoperable layer 1 protocols. And we'll get into that a little bit as well. And then there's a theoretical layer 3 protocol, which would be the accessibility layer. This would be so far away from the underlying execution that you wouldn't even know that you're interacting with blockchain technology. For example, the layer 3 protocol would be the user interface where they're interacting with several bridges and different chains and layers potentially simultaneously without even knowing that it's occurring on the back end. So that would be the furthest away from the execution layer. All the transactions must be finalized on a layer 1, and all other potential solutions to one or more of these issues presented in the blockchain trilemma are represented depending on the different variations of layers. So a layer 1 protocol. This is probably the easiest one to understand because it's the main layer of all blockchain technology. The layer 1 is where the execution occurs. It's the one that we most frequently use when we're interacting with decentralized applications. So what is a layer 1? Well, as we've said, it's the underlying blockchain infrastructure where all transactions are finalized. This means it's the core protocol that governs all the functionality, restrictions, consensus, and security for all the decentralized applications on the network need to abide by. There are many layer 1 blockchains that exist today, and there are several use cases in which many of them try to fill. There are some key flaws that limit their growth potential, mainly when it comes to Ethereum scalability. So as we know that Ethereum and Bitcoin are two of the most secure and decentralized networks. However, they lack the scalability side of the blockchain trilemma. So let's go over the generations of layer 1 protocols. In the early days of crypto and blockchain, some of the early projects were mainly P2P payment networks, meaning peer-to-peer payment networks. And these were all non-EVM because Ethereum hadn't been invented yet. So, some of the leading projects, obviously Bitcoin was the one that brought it into existence. And then other competitors such as XRP, and then eventually various Bitcoin forks, including Bitcoin Cash and other copycats like Litecoin and then Dogecoin and things like that. Those were the initial layer 1 protocols. Following that, then Ethereum was finally invented, which brought the EVM, which the EVM is a very significant invention. It allowed for Turing-complete smart contract execution in a decentralized virtual machine. What that means is it brought a new kind of network that allowed for any sort of computation to be solved in a way that's distributed with everybody, with all the nodes. So we can see in the early project section, we see like a green symbol for Ethereum. This was technically the original Ethereum network that was subject to a hack way back when, and then eventually had to hard fork to to Ethereum as we did know it, but it also just forked again into the POS version. But we'll talk about that. That's actually one of the limitations of a layer 1 protocol. But as we can see, some of the present leaders when it comes to layer 1 protocols are EVM compatible smart contract platforms. And then we can also see that there are some projects that had other ideas on distributed smart contract computing, and they've created their own solutions. So these examples would be smart contract platforms like Cardano, Tron, EOS, Solana. Tron is actually the biggest non-EVM smart contract platform by far. So as we went over, the early layer 1s were made to be decentralized peer-to-peer payment networks. And they were mainly Bitcoin copycats or other versions that were supposedly faster, such as XRP and Stellar Lumens. Then the invention of smart contract platforms came into existence. And the interesting thing about Ethereum and other smart contract platforms, at least a lot of them, is they're made to be general purpose blockchains for any use case imaginable. This sounds amazing because they can be applied to so many different things. However, there are some issues there that we'll get into further in the presentation. But the introduction of smart contract platforms also allowed for developers to build dApps, tokens, and fully programmable money for the first time. So whereas a peer-to-peer smart contract or a peer-to-peer payment network like Bitcoin, you can't really program too many things. It's good at what it does, but you can't create applications on top of it. Smart contract platforms and this generation of layer 1s really transformed crypto into a place where any decentralized application can exist other than just peer-to-peer payment systems and tokens. Ethereum's development had such a profound impact that the Layer 1 smart contract platform landscape split into two distinct categories. These categories are EVM compatible and non-EVM compatible. What this means is basically all smart contract platforms that exist are either compatible with Ethereum or not compatible with Ethereum. And that means that EVM-specific networks use Solidity for their smart contract programming. They're executed in EVM environments, and all these networks can be identified by whether or not they're basically compatible with your MetaMask wallet. So if you're unsure if it's an EVM network, if it works in your MetaMask, it's likely EVM compatible. Other non-EVM networks, they use different programming languages, some that are more common than Solidity, specifically C++, Rust, Golang, and they often use WASM as their execution environment rather than EVM. And this is significant with the approaching, ETH 2.0, the full takeover. Ethereum will be moving from the EVM to Ethereum WASM, an ETH-specific version of WASM, which will allow it to be more interoperable with other non-EVM networks as well. So that's a big development that's probably pretty far out. But another way to tell if it's a non-EVM network is if it has its own wallet solution or other solution than MetaMask. One significant limitation of a layer 1 network is the inability to upgrade the network as needed. So what happens when you upgrade Ethereum or Bitcoin or change its underlying code? The network must undergo what's known as a hard fork, which basically creates a whole new network and continues off where the last one left. But a lot of times the original network continues existing on as the community continues to mine on that network and do other things. So, one example would be Ethereum. The hard fork from Ethereum Classic to Ethereum, which then now there's a new hard fork, Ethereum Proof of Work network, which is the original Proof of Work Ethereum network that's now existing, just solely run by the community of miners who want to continue mining with proof of work. So it's interesting that things like this can occur and the old networks continue living on. Another sort of controversial example for the time was the Bitcoin Cash fork. When Bitcoin and Bitcoin Cash forked into two separate networks, there was a lot of debate between the community and engineers on how to process transactions in a more efficient way, which inevitably led to a new network that was slightly different, which is Bitcoin Cash. And then we have other Bitcoin forks such as Bitcoin SV and things like that. So when it comes to layer 1 protocols, we can see that you can choose two sides of the blockchain trilemma. And the two biggest protocols, Bitcoin and Ethereum, are very decentralized and very secure. So what they lack is scalability. One reason for this is general purpose blockchains such as Ethereum serve a wide variety of use cases, including but not limited to NFTs, DeFi, file storage, and much more, right? The use case is almost infinite. What this means is, since the gas fees are paid by network users to miners for validating transactions, and miners prioritize transactions based on the highest fees paid, executing transactions for a wide variety of use cases is inevitably not feasible because it leads to a lot of congestion and very slow speeds when a lot of different things are attempting to be executed simultaneously on the network. So the solution from this problem was the layer 2 networks. So what is a layer 2 network? A layer 2 protocol is the off-chain computing and transaction bundling layer. A layer 2 protocol would not exist without its underlying layer 1. What this means is a layer 2 network is essentially an extension of the mainnet network, which it finalizes the transactions on. So what it does is it moves transaction computation off the underlying mainnet, specifically Ethereum in most cases. It processes them on their own chain using different strategies for validation. These mainly come in validity or fraud proofs. After they're proved, then they're what's known as rolled up.
So guys, if anyone has any questions, Shivam will be taking it up. So we just wanted to make sure that all your questions are answered. So anybody wants to take it up?
Yep, if anyone has any questions, they could either ask me now, or maybe you could just just write it down while you're watching it if you don't want to ask it now. But yeah, if anyone has any questions till now, feel free to ask me. Just feel free to ask me. Don't feel like, okay, it might sound stupid or something like that, because it's something that it's not very at the ease level. So you may have a question. It could be anything. Just feel free to ask about it. And things happen, when I was doing my first talk, I fumbled Ethereum is a layer 0. So it's a layer 1 now, with this specific slide. So don't feel like you may do a mistake or something like that. If you have any questions in mind, just let me know. Okay, perfect. I think we are good to go. So we'll just continue with the workshop as well. And if you guys have any questions, just note it down. We'll just have another checkpoint as well. One. Perfect. Yeah. See you now.
We actually have a question, Shivam. We were actually outside and we discussed it. We'll get back to it later on. We have a question. Yeah, so guys, once again, we can start with the presentation.
So roll-ups are created, which essentially are just bundled transactions that are then appended to the underlying layer 1 network using various strategies to reduce the transaction size. One common way is the roll-up is posted on Ethereum under the call data as opposed to being executed as an actual transaction. And this, what this does is it reduces the need for gas payments. So when it comes to rollups, there's zero-knowledge rollups or optimistic rollups, and we're going to talk about that as well. All transactions are processed on layer 2 networks, then are later finalized on their respective layer 1 network. So anytime a layer 2 processes a transaction, it's not actually completed in its finality once it's appended until it's appended to its layer 1 network. And in most cases, this is Ethereum that we're speaking of. However, the original layer 2 network was actually on Bitcoin. So the Lightning Network is a layer 2 network built on Bitcoin that aims to increase the scalability of the Bitcoin network and also usability of the Bitcoin network. However, when talking about layer 2 networks, the main ecosystem that we're speaking of is Ethereum. So just a quick overview of all the different layer 2 ecosystems built on Ethereum. So we start with Ethereum. This is the main net where all the transactions are finalized. And then we have different layer 2 scaling solutions. So these two would be optimistic scaling solutions, and then these ones would be zero knowledge. The interesting thing about Polygon is it has a lot of different solutions, which we're also going to talk about. So what is an optimistic layer 2 network? Optimistic networks use optimistic rollups to increase scalability of ETH mainnet. They assume all transactions are valid unless proven fraudulent, using fraud proofs, hence the name optimistic. So some of the pros of using an optimistic rollup is they're incredibly simple to build. They're natively EVM compatible. They have cheaper fees than Ethereum currently has, and they're compatible with all Ethereum tooling, and they also use Solidity. However, there are some cons when it comes to optimistic rollups, which are they're less secure than their leading competition, which would be validity proofs, since they assume transactions are valid until proven fraudulent. Optimistic rollups are less scalable than ZK rollups as well, and they kind of seem more like a temporary solution or a specific alternative that wouldn't be as good as zero knowledge. So these ones currently have more activity than their competitors, the zero knowledge rollups. And these projects are Arbitrum and Optimism. They both support Solidity and EVM natively, and these are the leading optimistic layer 2 networks today. When it comes to the zero knowledge space, it's a lot further behind in terms of actual adoption. However, there's a lot of promising innovation that can come from zero knowledge blockchains. So one thing is ZK rollups can boost scalability using two different types, snarks or starks. And ZK blockchains use validity proofs in order to solve for transactions. And what this means is instead of proving that they're fraudulent later, it determines that there's no way it can be fraudulent prior. So it's almost the opposite approach than optimistic rollups. And what it does is it verifies the transaction first rather than later. They also enable increased privacy, account abstraction, on-chain machine learning, and purpose-built layer 2 networks. The idea of purpose-built is going to be important in the conclusion of this presentation. So some pros of the zero-knowledge blockchains are they're the most secure and scalable solution that we've currently have devised. They have advanced functionality that are not restricted by EVM limitations. Some cons would be they're very complex still, and they're not natively EVM compatible. There's a lot of customizations that need done in their virtual machine environments and things to allow them to operate in an EVM network. They're still largely under development, only just now kind of coming on the market and on testnet and things like that. And each have their own unique programming languages typically as well, which is another limitation to adoption, developer adoption. And then we have the Polygon network, which is a layer 2 aggregator. What this means is they provide several different roll-ups and scaling solutions, both optimistic, ZK, and others. So Polygon is really trying to provide scaling solutions to meet any use case, which is impressive. So big shout out to Polygon. So some key takeaways from the L2 category is Optimistic layer 2s are simple to build on, but are slower and less secure than ZK-based layer 2s. ZK-based layer 2s are very complex, but have higher throughput and security than optimistic layer 2s. Optimistic layer 2s are great for right now. However, ZK-based layer 2s seem to be the future of Ethereum scaling. Now that we've covered layer 1 networks and layer 2 networks, I think it'll be a little bit easier to understand the concept of a layer 0 network. And basically what that means is it's just a common framework for modular layer 1 blockchain development. So to get into that, a layer 0 network, some examples would be Polkadot, Cosmos, and those are really the two big ones. One thing we can see is that after Ethereum, according to Masari research, Polkadot and Cosmos have the highest development activity after Ethereum mainnet. And we have some reasons why that would be. So, for example, what is Polkadot and Cosmos? Polkadot and Cosmos is a network of purpose-built layer 1s. So what does that mean exactly? A purpose-built blockchain means that it's built for a specific purpose. It's not a general purpose blockchain, for example, like Ethereum or Solana, where you can build any application on it. A purpose-built blockchain is a blockchain that's built for a specific use case, which can be DeFi, it can be an NFT marketplace, it can practically be any purpose you can think to apply blockchain technology to. But just a limited scope of what that purpose is. And why is that important? Well, purpose-built L1s on these different layer 0 networks like Polkadot and Cosmos they have a more robust and efficient ecosystem in terms of communication between dApps and compatible chains. It also allows you to have fully self-sovereign L1s with customizable governance. Basically, a layer 0 network allows you to deploy your own layer 1 using modular code and totally customizable metrics. This is really great because it allows for native cross-chain interoperability and communication with chains on the same network. And it also allows for every layer 1 to benefit from shared security of the common consensus framework of the protocol. In addition, there's also enhanced upgradability, which means that there's no need to hard fork for network upgrades anymore using Polkadot and Cosmos. So to look at some examples of what a purpose-built network is, we can look to different layer 0 and layer 2 innovations that currently exist today. So looking at Polkadot and Cosmos, we can see that they each have their own EVM network. That's interesting because that means that they're basically, some of these projects literally exist to connect these networks back to the Ethereum ecosystem, which, because it's so large, it's almost a disadvantage to not be connected back to the Ethereum ecosystem in some way. So we can see some other purposes for different networks and different projects in those categories. On Polkadot, we have some Akala as a DeFi layer 1 network, and then we have some on Cosmos as well as on Starknet, which is a ZK-based layer 2. We have DYDX, which is a pretty big derivatives trading on Starkware technology, and Immutable X, which is built on ZK Starknet technology as well, which is an NFT marketplace, and SoRare is also an NFT, sports NFT marketplace. And we can also see some other use cases for purpose-built networks that include cross-chain communication, bridging, various infrastructure things like file storage, privacy, IoT technology, supply chain management, and pretty much anything else. So looking at the network usage across these different types of chains and ecosystems, we can see some startling metrics here. So to start, we can see across all smart contract platforms specifically, there's been 47 billion total in TVL. 60% of this TVL is currently on Ethereum mainnet itself, with only 14% on non-EVM networks. So EVM sidechains capture 20% and Ethereum layer 2s capture 6% of all TVL. EVM layer 1 and layer 2s, when we look at those specifically, we can see that the top EVM protocol is Binance Smart Chain, accounting for 54% of all EVM liquidity locked. This is excluding Ethereum. So every EVM protocol besides Ethereum itself, Binance Smart Chain accounts for 54% of the total 12 billion locked. But then you can see it's a little bit closer competition between Avalanche and then two other Ethereum layer 2 networks, Arbitrum and Polygon. When looking at non-EVM layer 1s, we can see that Tron is the clear leader, accounting for 68% of the total 6.4 billion locked. And all the other platforms combined account for 32%. But one thing that's interesting when it comes to non-EVM layer 1 networks and their competition between them is how close it actually is. So we've seen several non-EVM layer 1 networks, giant ones, kind of crash in the past couple months. For example, Terra Luna and Solana have both decreased in TVL drastically. So now that has happened, there's really kind of an even playing field between all these different non-EVM layer 1 networks. And to put these into perspective, these are only accounting for 2 out of the total 47 billion in TVL across all networks. So when you take out Tron, Ethereum, and all EVM networks, what you have left is this. When looking at this graph of EVM versus non-EVM networks, excluding Ethereum mainnet, we can see that EVM networks account for 66% of the total value locked across all networks minus Ethereum. This includes EVM sidechains and Ethereum layer 2 scaling solutions like Polygon, Arbitrum, etc. This leaves 34% of the total 18.65 billion locked in all networks, excluding Ethereum, left on non-EVM networks, mainly Tron, and then the even split that we saw between all the other L1s. The most startling statistics here are the EVM versus non-EVM TVL. When you include Ethereum itself, we can see that 86% of all TVL locked in smart contract platforms are on EVM compatible networks, including Ethereum, EVM sidechains, and Ethereum layer 2 scaling solutions, leaving only 14% for non-EVM networks. So to conclude, how do we piece together all these different concepts and different layers and metrics into a meaningful analysis of the current state of the industry and where it's heading in the future? To start, I think it would be helpful in having a high-level overview look at the evolution of the blockchain layers. So to start, we can see that early iterations of layer 1 protocols included Bitcoin and other peer-to-peer payment networks. These layer 1s solely existed as a means of payment between two different people in a decentralized environment. Moving forward from there, the invention of Ethereum brought smart contract platforms into existence. The early iterations of smart contract platforms mainly exist as general purpose blockchains, and these are also the majority of platforms that are used today. General purpose blockchains are useful because they are fit for any use case, so you can build any type of decentralized application on them. However, they're limited since there are so many different use cases being built on top of them, the network congestion gets a little crowded and then gas fees get high. But the invention of Ethereum was so impactful that it basically spawned two different types of categories of layer 1 blockchain protocols, specifically smart contract platforms. And this was EVM or non-EVM. So competitors who adhered to EVM standards have traditionally seen higher growth potential because it allows for quicker access to the liquidity of EVM networks, as well as users are more familiar with the fundamentals of EVM protocol and the user experience around that. However, because of Ethereum's limited scalability, Layer 2 protocols started to emerge, which moved computation off of the mainnet chain and onto other Layer 2 chains, which process the transaction, bundle it, and then execute it back on the Ethereum mainnet in a more efficient way. And these solutions solely exist to benefit Ethereum mainnet. Some of the most interesting of those solutions are zero-knowledge Layer 2s because they offer the highest security and scalability while also unlocking new potential features for blockchain technology that have previously been impossible or unexplored. While they're promising, their realization is still years away, as many of them are largely under development still. And finally, purpose-built Layer 1 blockchains. These are made possible by Layer 0 protocols such as Polkadot and Cosmos. And building with EVM allows for simpler interoperability between different chains that are also EVM compatible, which is majority of the most used ones, as well as the different protocols built on those chains and the developer tools and programming concepts and things like that, tokens. It allows for easier cross-chain deployments since the underlying programming language is Solidity-based. It allows you to quickly scale across the different compatible networks as they all use Solidity programming. It also increases your chances of gaining a user base faster because most of the liquidity is currently on EVM networks, as well as that's where most of the users are. And being EVM compatible will offer us a similar user experience that other EVM networks offer. When looking at Ethereum scaling, we can see that optimistic Layer 2s are currently leading in terms of TVL and users. And this is because they're the most readily available solution. However, we can also see that zero-knowledge Layer 2s are slowly coming into production, and there's a lot of anticipation behind the potential breakthroughs that they'll allow for, including account abstraction and several other things. In addition, we can see that non-EVM networks are in tight competition with each other when looking at TVL. When you exclude Tron from the equation, it's a pretty even split in terms of percentage when we're looking at other Layer 1 protocols that are non-EVM compatible. This isn't surprising, as a lot of these non-EVM networks are also purpose-built Layer 1s that are all kind of part of either the Polkadot or Cosmos ecosystems. So we can see that all these different purpose-built Layer 1s are sort of kind of filling equal TVL numbers. And that's just roughly. But majority of developer activity is also occurring on these Layer 0 protocols, Polkadot and Cosmos, which are majority comprised of purpose-built Layer 1 blockchains. Looking forward, we can assume that zero-knowledge-based solutions will be the catalyst for the next evolution of blockchain technology, and they're also the brightest future for Ethereum scaling. This is because of the various concepts that they will support, including account abstraction, purpose-built Layer 2 networks, as we've seen in Starknet with Immutable X and DYDX. ZK-based solutions are also private by nature because the way that they work is when adding new transactions to the chain and bundling those transactions in a ZK rollup, the data surrounding the transaction, including the user behind it, is left out, which reduces transaction size, but also makes for the solution to be private natively. In addition, ZK-based solutions offer maximum scalability for any use case. On another note, layer zero, layer zero networks such as Cosmos and Polkadot, I believe will continue to gain market share as well as continue to grow on the developer side. This is because instead of applying short-term kind of band-aid solutions as kind of the Ethereum Foundation has continued to do as ETH 2.0 is rolled out and Ethereum scaling is maturing, there's a lot of short-term kind of fixes for longer-term development projects and problems where with Cosmos and Polkadot, these layer zero networks are building a better ecosystem from the ground up, which include less limitations since they're not bound by EVM inefficiencies, where all the different most used layer one networks right now that are EVM compatible, they're bound by a lot of restrictions that the EVM puts in place because of just its inefficiencies overall. Also, I believe that these ecosystems are attracting developers who are building with a longer term outlook, and that is because the user base is likely to grow slower than it would if they were building an EVM compatible network. And this is because of the fact that most people are already using EVM networks, and that's where all the activity is happening. People building on a layer zero, such as Cosmos or Polkadot, who are working on purpose-built layer ones, they're focused on building better products with more focus rather than a one-size-fits-all solution that we see in most EVM networks today. A better value proposition than standalone general-purpose non-EVM blockchains. So the value proposition behind these purpose-built layer ones really has to be strong for them to succeed. However, all the different use cases that they can fill together in a compatible network is one theory on how to better solve the blockchain trilemma. In addition, the EVM space is overcrowded and sort of redundant, and they're mostly short-term scaling solutions or just other copycat networks with their own communities and developer ecosystems as well. But EVM compatibility is becoming so common, and especially as ETH 2.0 migrates away from the EVM and towards eWASM, that will also increase interoperability with non-EVM chains, making the need to be EVM compatible sort of obsolete, since it's all going to work together, whether it's EVM or WASM in the future. Interoperability is almost a given. So building right now on an EVM-based ecosystem could be a limitation when there are potentially other better alternatives out there that are not EVM compatible. Going back to the blockchain trilemma, we can see that zero-knowledge scaling solutions and layer zero networks are the closest to solving this actual problem. That's because with zero-knowledge scaling, we're able to maintain the same level of security and decentralization that we're used to. However, we get way closer to the scalability. Actually, it solves the scalability problem, thus creating the solution to the blockchain trilemma. However, another possible solution to this trilemma is also the layer zero networks that allow for an infinite amount of purpose-built layer one blockchain networks to solve specific use cases within their interoperable ecosystems. And this solution will continue to grow in popularity as the industry matures. So that is all. Thank you everyone for listening to this presentation, and feel free to ask Shiv on site any questions you may have regarding any of the information presented here today. Don't forget to go like on Twitter and go subscribe to Morales Research. Thank you.
Wow, okay. I think we can clap again. Yeah, that's great. So we'll be following up with questions. Yeah, Shivam, you want to take that?
Perfect. So yeah, that was a lot of blockchain knowledge packed into one workshop. So if you guys have any question, we can go through them. Like any basic question, any terminology that you didn't understand, or anything that you have in frame. What? What's gas fees? Yeah, so let's say you are doing a transaction on chain, right? And then someone has to do the commutation for that. So it's probably like a fees that you pay for that transaction to go ahead. That's basically the gas fees. So if you see the trilemma that he shared in the start, right? Like either it can be very scalable, either it can be decentralized and more, right? So gas fees is basically a problem when, let's say for the Ethereum network, right? Like there's a lot of people doing a like lot of people using that, and there's a lot of congestion there. That's why gas fees is traditionally high there. So I just assume that maybe you're asking because it's quite popular with the Ethereum size, right? Ethereum size, right? But how Polygon Matic reduces is like, let me give you a very, very simple example, like human example here. Like let's say like this side is Ethereum, and every transaction that has to be done, it has to be done this side, right? If I shift you all this side, then you probably have very less space to be here, right? It's very congested, and it's not too, you could say not too comfortable here, right? Basically, exactly the same way when there's a lot of congestion in the Ethereum network, right? There's a lot of work to do, so gas fees tends to go higher. So that's why he shared about the layer 2 solutions like Matic and that other that are building up. So those will, as you also might have heard in the presentation, right? They make sure the transaction and everything is done. Once it's like, sure, yeah, this transaction is valid and everything, it just has to be recorded on chain, then it comes there. So it's not like a lot of transactions, everyone is just getting there. It's like we can sit all as we are, and once it's finalized, it reaches down. So yeah, that's about your question. Anyone else? Check. Okay, I said check and someone just woke up at that side. But yeah, anyone else? What? Forking. Yeah, that's a good question. So she asked what's fork, right? Like what's forking and what are basically forks? So let's say that we all are a community, and let's say we are all the participant of a specific chain, right? And let's say at some point in the time, some of us think in a different way, and some of us feel like currently Ethereum switched to proof of stake, right? Then we had also another chain called ETH-POW that didn't got much of the interest from the people, you can say, but that basically became a fork. So it was like Ethereum network was doing proof of work. Every transaction was coming, it was being validated based on proof of work methodology. And once they built the proof of stake system, everyone shifted to that proof of stake system. But let's say some of them didn't agree to that ideology, right? So they instead thought to go another route. So they're like, okay, you continue with your proof of stake new system, but we'll just continue with this proof of work system. So they forked or made just another, you could say, a project or community out of the same one. So it's usually the forked system is the original one, you could say. It's basically like, let's say I built something today, and then I have some ideas to improve this. But some of our community members think that, okay, this might not be too wise. So in Bitcoin, it's usually a lot of fork cases were discussed when they wanted to increase the block size, like how much a block can store, right? How much data a block can store and how large it should be. So if a community comes up tomorrow and says that, okay, I want to increase it, like I want to make a GB of a block size or something like that, if not everyone agree, obviously not everyone will agree, but the people who will agree, they will use the same code, same blockchain, and they'll run it on their separate system. Maybe you could say they'll run a separate system out of it. So yeah, that's basically a fork in simple terms. But yeah, anyone else? Anyone else? Yeah, please.
So Shivam, I think I'm speaking for all the students here. You said you don't have a lot of Bitcoins. So I think everybody wants to know how many do you have? Do we want to know that? Yes. I mean, I didn't listen properly. Do we want to know that? Yes. Okay, I don't want to put Shivam in a tough situation. So here's what I'll do. What I'll request all of you to do. So just go on our IBC Twitter handle or on Discord. Okay, just go for Twitter. You can just check us out at @IBC media _ Just put in a comment that Shivam tell us something like that. Okay, and we'll make sure. I'll try my best to make sure that I persuade him to answer that, and I will definitely reply all of you personally to your question. So, but you put that up online over there. I don't want this to be recorded. If you want to take something up.
Yeah, I just want to say, like, I was very interested to share about my social handles. Like, I was thinking, like, maybe in the next talk that I'll have, I'll just say, like, okay, you can tag me @ something, which is my Twitter handle. I'm not going to share it now, definitely. You're all going to blast me there. Okay, how many?
I'll put that handle to all of you over there. I'll put that handle to all of you there. Don't worry. We all will be hunting you for that.
That's in crypto. Basically, it's saying like, okay, nice try FBI. So it's like, let's say, like FBI basically, like most of the centralized government entities, for obvious reasons, they just want to track how much a specific person owns, right? Because like let's say if a random entrepreneur is there and he has a crypto startup, he has raised a lot of funds in crypto. So they'll try some hacks, like some random person will go and they're like, okay, can you give me a wallet address because I want to share an NFT for access of for a specific event or something like that. Basically, it's an intent to get your wallet address so they can track whatever you own. So that's what I would like to say to Deepak, like nice try FBI.
No, but if the students, if like a couple, 50, 80, 100 students, I'm going to call you, I'm going to be behind you to make sure that you answer them. But yeah, I mean, I can persuade, that's all I can do. But I really appreciate the fact that you took that up. I think we have a question back there. I would request, yeah, sure.
Hello. In the network layer, he said about EVM now, sir.
Yep.
Can you explain it briefly, like what is the role of EVM in that, how it changes the code and all?
Yep, so he talked about network layer and he discussed about EVM, which is Ethereum virtual machine, right? So what he was sharing there is exactly layer ones, like let's take example of Ethereum, right? When you, like Ethereum is basically built on EVM and you can make a lot of other chains which are Ethereum compatible as well. I assume your question is in link with like how EVM plays a role in different layers, right? Just correct me if I'm wrong. But yeah, if that's the question, then yeah, like EVM is a layer one, but what he wanted to share is like, let's say if you are making a dApp, right? A decentralized application, and you want to make sure that you get a lot of reach as much as you can. So if you're making on layer one, then basically all the chains which are layer one and EVM compatible, they can access it, and layer two solutions which are built on EVM, which is Ethereum virtual machine, they can access it, right? So, but yeah, if you go to layer zero, like Polkadot, which is one of the ecosystem partner, right? Shout out to them as well. So if you're building something on layer zero solution, right? Then that ensures that it works and compatible with others as well. But if you have, like, if you could just elaborate your question more, like what exactly you meant?
I mean, like if we have a transaction in layer one, and how it is converted and how it becomes compatible with layer two. Like, does he use some code, or the machine converts it to something that is machine understandable, or like that?
Yeah, so basically it happens slightly differently. So it's like like when we talk about layer twos, right? Like when we use layer twos for scalability, then transaction actually occurs on layer two. Everything is finalized, then it comes on layer one to be, you could say, like maybe added to the chain or something like that. So it's like, as I gave a previous example, right? Like let's say everyone is just going to clutter that site. That's like everyone is just going to one specific source. Let's say if let's just go very, very like ancient times, and let's say we are not at all in computers, we are just in the books. So let's say if I am a layer one, it's like I'm writing all the transactions in the book, and you could think of a layer two solution as another person who is there, who is writing the transactions and doing everything, and then he is coming back and adding in the same ledger, if that makes sense. Perfect. Anyone else?
He used something like it is optimistic until the transaction is seemed to be fraudulent, right?
Yep.
So what happens when the transaction is fraudulent? The previous transactions are also cancelled, or are they aborted, or they continue the previous ones?
Yeah, I'm not exactly sure about that because that's expertise of Spencer, but maybe I could comment like how it would work is how I would assume is let's say like optimistic transactions will be like added, and once it's proved fraudulent, it will be removed. So probably there should be a bandwidth or time gap. I'm not exactly sure to comment on this, but I'll just say like maybe there will be some time where anyone could pick it up and maybe prove, okay, it's a fraudulent transaction and remove it, or once it's added, it's just added, if that makes sense. But yeah, optimistic is just one way of scaling solving the scalability problem. Like you could use zero knowledge proofs as well. Yeah.
And can we transact like little amounts also in these bitcoins using bitcoins?
Yep, you could transact as little as like I'm not sure how much on a how much on a specific blockchain, but you could transact even like 10 Matic or something like that. If you're doing on Polygon, that's basically like how much? It's $0.8 now, so probably $8. So yeah, you could transact like 400, 450 rupees as well. If you go to centralized exchange, you can even do a transaction even lower than that because you don't exactly do a transaction on chain there. It's like all your keys and everything is with them. So you just basically purchase, so they purchase it for you. So yeah, on centralized exchange, like you see CoinDSec and stuff, right? You could do even 100 rupees of Bitcoin. So yeah. Perfect. Thank you for the questions. Anyone else? Yep, please.
We have seen the stats showing that the EVMs are popular than non-EVMs.
Yep.
But what exactly makes EVMs popular and so special?
Yeah, so that's a good question. So why EVMs are very popular and why we have a lot of people building on EVMs, right? So the thing is, if you see the most adopted smart contract platform that came after like that came earlier, right, was Ethereum, and it uses Solidity programming language, which has been quite old, right? It's not very new. So there's a lot many people there. There's a much happening there. That's why it's like more people join in there and it grows that way. It's just that.
So non-EVMs are new to blockchain.
Yeah, you could say non-EVMs have come up later. Like if you see Solana, which is a non-EVM chain, right? It came after Ethereum and now it's building its community. It has its own benefits. It shares it with the community. Community feels like, yeah, this chain is something good. Okay, this adds value in this certain way. And then people like it, they go buy it. It's just basically like, you could say like, you could basically ask like why Android has more users than iPhone. It's basically like people's choice. It's like more development there. It's already a lot of tools, already a lot of dApps built there. So you could just start picking up from there. That's why. And also one thing that I would share more at the end in more detail, but I'll just brief it now, is like it's not that easy to build on chain, right? You know, like I'm sure they will make it very easy in this duration of Hackfest, and they'll make sure that every one of you are skilled enough to do that. But if you're just starting out, it's not that easy. Even if you just want to read out transactions, right? Like even if I just want to say how much, like as Deepak asked, how much Bitcoin I own, I need to go back through all my transactions, calculate it and do it. So dApps do it for you, other applications do it for you, right? So yeah, those applications and ecosystems are much more matured in Ethereum side now, so they are there. But yeah, there's a lot of great tools as well that you could use to simplify the process. We'll talk about that at the end. Perfect, thank you. Anyone else? Or we can go by the next workshop. Anyone else? Okay, perfect. I think let's move on with the next one, Deepak.
Yeah, just a note that I know all of us are hungry and nothing goes inside the head without something in the tummy. So right after this workshop, we'll just finish this workshop and then we will move on to our lunch. So the next session is basically on blockchain technology architecture. In blockchain tech, there are several critical things. One is consensus. How do you agree upon a node? Where do you want to store a data? And how do you process transactions? This is like the nervous system of blockchain. There are some important considerations that define the blockchain architecture. And let's delve in it further and hear from our next esteemed speaker, Mr. Philip Norman. Mr. Philip is heading events and research at Morales, and we are eager to listen to what he has to say.
Greetings, hackathon and event participants. Thank you so much for having me here today, and special thanks to IBC Media for inviting us at Morales to present with you guys today. My name's Phil, head of events for Morales, and I'm also head of research for Morales. I work heavily with our research team to produce a variety of different in-depth reports on current blockchain issues each and every week. Some of our other researchers are also presenting at this event today as well. And during this particular workshop, we're going to get into blockchain architecture. Now, this might be a little different than other blockchain architecture workshops you may have attended in the past, by which I mean I'm going to be explaining everything in terms of how it exists based on all the different factors that we see going on today. Some of these definitions will be less academic and more practical to the current state of blockchain. And so I look forward to exploring this with you here today, and I also welcome any questions via the various social media outlets that I'll present at the end. Let's get right into it. So what is a blockchain? Well, when we talk about blockchains, we're talking about really a variety of different pieces of technology that come together to create a new internet experience that we're all experiencing right now when we use these new pieces of technology. The first one is a public database, and I'm going to get into that in a little bit. Now, this is distinctly different from other public database alternatives, not necessarily in function, but in the way that it stores data. And we're going to get into that a little bit too. Also, a public compute engine is a commonly referenced utility for the blockchain. And we're going to talk about that as well. We're going to talk about three-point accounting, the Ethereum virtual machine, which is a specific compute standard that is most prevalent today in blockchain architecture, especially useful in producing DeFi functions, which are on-chain financial products which operate trustlessly. We'll talk about that a little bit as well. And lastly, we're going to talk about blockchain's role in Web3 and maybe a little bit about what Web3 is today and what we hope it'll become in the long run. So what is a public database? I'm sure that you've heard of public databases like MongoDB, and other organizations offer some public offerings as well. These are databases that anybody can put information in. They may offer a paid API that allows you to store more data or access the data more frequently or at a quicker speed. Things like this serve to increase the usefulness of these public databases, but by and large, when you put information on a public database, you're publishing it for anyone to view. Now, there are schemes that we can involve in order to base. We could otherwise obfuscate it and separate the data into multiple parts, and in which you would have to know the location of not just one piece of data, but multiple pieces of data in order to recombine them and actually produce the information that we're looking for. All of these things can be done, and this is where blockchains actually have a ton in common with public databases. Just like a public database, a blockchain can be published to by anyone, especially permissionless blockchains, which is what we're going to be focusing on today. It doesn't matter where you are in the world, so long as you're able to connect to at least one node on the network, it's possible to publish a transaction to that network on a pay-per-use basis. And that's basically what we're talking about at the most basic sense when we talk about blockchains. We're talking about public databases that are pay-per-use. And this is where we get into utility tokens. Utility tokens are the most basic asset that exists on a blockchain, and their value is directly derived, at least in most cases, from the utility they have within that network. Now, there is some speculation that takes place where Ethereum poses a good example. People are buying Ethereum in order to sell it later at a higher price. You know, that is what we would call speculation. Now, does that adjust the price away from what the utility value is of Ethereum? Potentially. However, in the long run, it's reasonable to assume that the value of Ethereum would actually be related to the cost to publish data on this public immutable database. And maybe that's one of the other advantages that we often attribute to blockchains, is that once data is published on there, it cannot be removed. Now, it would be possible to do all sorts of different functions from the address that you control regarding that data that you've published on there, but actually removing the data entirely would be a technical impossibility. And that's because when we're talking about blockchain ledger and when we're talking about blockchain databases, we're talking about a continuous amend-only database. So unlike things like I mentioned MongoDB earlier, where it may be possible to actually delete your data and remove it completely later on, with blockchains that isn't really possible. And because of that, we need to think very carefully about what type of data we put on there. One use, which has gained the most traction since the conception of blockchain, is the transfer of value. And that's because having a permanent, unchanging record of financial transactions is not only useful, it's actually a second evolution of accounting practices, which we're going to get into later on. So moving on from blockchains as public databases, they become even more interesting and more complex when we consider the fact that the database is not only publicly amended, it's publicly hosted as well. So what does that mean? That means that we need only one node live in order to access the data published on a blockchain database. Every single node within the network holds 100% of the database information. And now this is, I'm of course talking about blockchains in their earliest incarnation, which does not involve any kind of theoretical sharding or other types of data distribution that might increase scaling. When we're talking about blockchains in their most simple form, we're talking about a ledger which is shared by every single node in the network. And then that's becomes a resiliency point at the same time as introducing a great deal of collective thought with respect to everything that's published on that chain. So even when you are the single originating source for a piece of data, you're participating with other members of that chain in order to get that published to the blockchain, whether you're competing as a miner or paying a miner to publish that data to the chain for you. At the end of the day, what we're left with is a publicly owned, publicly maintained, unchangeable database that has full global consensus at all times. So what about compute? How do we compute? Well, computation is something that we're very familiar with in this day and age. Over 50 years since the invention of the simplest type of a computer, a calculator, we're looking at some of the most amazing compute engines that have ever been devised, and many of them fit inside of our pocket, like this phone here. Now, what is the value then in a new type of computation? Well, blockchains are capable of performing many of the same functions as a regular computer. Just like a computer or a cell phone or any piece of hardware with a central processing unit can compute data, solve math problems, and perform other functions, which may even eventually add up to produce the equivalent of a financial service, which is currently only available in manual form in traditional finance. Using a public compute engine, we can start to turn this into a public good that anyone can use and pay to access. So the advantage there is that everything becomes publicly verifiable and everything becomes publicly provable. Now, while on my phone, I could perform a series of computations and then share all of my work with somebody else so that they could double check me and make sure that I did everything correctly, make sure that my hardware is functioning correctly. With a blockchain that offers some sort of compute functions, as they all do in different levels. Ethereum's capabilities in this area are far more advanced than Bitcoin's, but both of them do contain the ability to process some computational functions. And when we put this on a blockchain, we do it in a way where everybody can not only verify it, but actually witness it while it's happening. And that verification and that universal witnessing produces outputs that we can trust. So from a system where we have thousands of different players of whom cannot trust each other normally because they all have conflicting interests, we're able to actually process and produce trusted results using a shared compute engine. So let's get into that a little bit more. Blockchain is global computing. For the first time ever, really, we're producing true global results using a computer system which none of us control solely. The exact specifics on how this works, I'm not going to get into during this one because I want to keep this on a top level where we can really start to understand the benefits of this technology as it exists today, more than the technicals of what makes it happen. A lot like when you go to, and I keep coming back to the calculator example. If you go on your home computer and you open up your calculator app, you don't perform any verification on the back end to make sure that calculator is functioning correctly. You simply trust it. And that's because there's been significant vetting of the calculator application across multiple operating systems. So whether you're using the calculator in OS X or you're using the one in Windows 10, there's so many different people that are using that exact same software, we know that we can trust it. Blockchains function somewhat similarly to that. When we publish a piece of code on chain, it becomes public immediately. Everybody who's holding that blockchain can view and verify that code and perform their own audit if they choose to. On the basis of that, we're able to begin to use software that we globally vet together in production. At the moment that it's put into production, it's put into the public domain of usage in a more real way than we've ever seen before. And this is what we're talking about when we say blockchain is global computing. Because it is, in its most pure form, it's us collectively coming together to verify the validity of a contract and then execute using the information that was published on that chain. All of this coming together to produce a product which is not the part of any one of us or any one of the node players, but a product of all the nodes working together. So this is where I get into accounting. In traditional accounting, it's always been the practice to maintain your own books, and then during an audit or other third-party intervention, the reconciliation of those books discovers what the truth is. It's not uncommon for two entities to have completely different books at the end of the day. And if they aren't able to come to agreement on the payments that were made using these systems, then it's necessary for them to amend these books in order to find unity between the two accounting systems and finally figure out where money is. This is where we see things like millions of dollars lost by an organization. In one set of books, it says that money should be there, and then in the other set of books, it wasn't properly accounted. For the first time ever, through blockchain technology, we can start to move away from the two-point accounting system and move into three-point accounting. Now, three-point accounting was first made possible with the introduction of Bitcoin, the most basic of cryptocurrency or blockchains available and out there. There's a certain stoicism in the market and in the development teams behind Bitcoin that very much want it to be a simple three-point accounting system and not to go beyond that. And we'll get to why in a little bit. But basically, the advancement comes in the form that when someone is publishing a transaction to a chain, whether that's an entity that's renting the services of a miner or is a miner itself, it is verifying that transaction with all of the other nodes on the chain. So the first accounting point is the node or node renter that wants to publish a transaction. The second accounting point is the consensus that takes place between the nodes in order to put this transaction on chain. And the third accounting point is the ledger that's produced by the blockchain. That same computational ledger that's used to produce pure worldwide computation is also used to maintain an immutable and permanently correct record of transactions between organizations and identities. Three-point accounting is truly the future of accounting, as it removes arguably the most major pitfall of accounting that we've ever had. But it does it by introducing a new monetary system at the same time. In order for three-point accounting to work in its purest form, the asset being used needs to be a blockchain native asset. It may be possible to introduce this using stablecoins for traditional finance. However, in that case, we would have to consider that the record keeping between the on-chain stable assets and the backing, which is likely fiat currency, that still needs to be maintained through traditional methods and cannot be guaranteed by the blockchain alone. For this reason, blockchain native assets such as Bitcoin, Ethereum, and other utility assets actually have an edge when it comes to value reliability because their value is derived from their utility, as explained earlier. This, of course, ignores the possibility of speculation on the asset. However, in the long term, it is expected that utility will drive the price more than speculation. And the reason for that is the value of things like three-point accounting. So how about a better blockchain? Is Bitcoin the best version of what a blockchain is? Some would say no. Now, while Bitcoin is certainly capable of all of the things that we've discussed so far, it's not capable in its current form of full Turing computation. And what that means is that the vast majority of computer programs cannot be deployed to Bitcoin regardless of the amount of resources available. It's simply not capable of producing the long-form computation that full Turing engines are capable of. Ethereum, however, is capable of this. And that's where we get into Ethereum Virtual Machine. Ethereum Virtual Machine is basically a computational standard for blockchains. Many blockchains support this computational standard natively. Ethereum is one of those blockchains. Other examples include L2s, layer 2 blockchains such as Optimism, Arbitrum, and others. There are also many layer 1, meaning independently running blockchains, which use EVM or hold full compatibility with the EVM computation model. This is a huge advantage because the vast majority of DeFi is programmed for Ethereum Virtual Machine compatible systems. So, if you want to bootstrap DeFi within an ecosystem today, you can do it using existing smart contracts, which are on-chain or on blockchain computer programs, in order to introduce DeFi to an ecosystem that does not exist. This can be done with other blockchains too, but the benefit of EVM compatibility means that you'll be able to deploy it based on its current configuration. So what's the next steps for this? Well, some blockchains have decided to introduce Ethereum Virtual Machine, or EVM, as a base primitive for the blockchain. Other ecosystems have actually introduced components or second layer chains in order to provide EVM compatibility. We see this with Polkadot and Cosmos ecosystems. I'm not going to go deeply into Polkadot and Cosmos during this presentation, but suffice to say that Polkadot has connected to it Moonriver and Moonbeam, one of those being connected to the Kasama ecosystem, Polkadot compatible, but not exactly natively connected in the same way. Different details on that in a different presentation. But basically, when you have these, what are sometimes referred to as layer 0 ecosystems, they have full blockchains which run on top of them. Those full blockchains can support any compute language that the developers desire. And in many cases, certainly in the case of Moonbeam and Moonriver, but also in the case of Kronos blockchain, which is a Cosmos connected blockchain, we're seeing full EVM compatibility, even in ecosystems which do not typically support that compatibility. This says to me, as a researcher and player in this industry, that EVM compatibility has major value within the current climate in terms of usability and quickly bootstrapping DeFi utility. So if EVM compatibility is the standard for on-chain computation today, and I believe that it is, then how do we improve from here? Well, the answer is likely through better smart contracts. Oftentimes when talking about blockchains, the question of how secure is this particular blockchain will come into play. And I've definitely fielded that question many times myself when talking with members of the community about which blockchain to use. The truth is that while blockchains do have security as a component of how they function, security of funds is equally the responsibility of the smart contract designer. So in order to introduce full security within these ecosystems where mainstream commercial users can trust their funds to an on-chain computer program, then we need to be building towards better smart contracts all the time. Some of the biggest pitfalls of DeFi, especially DeFi bridges, have come in the form of hacks related to smart contract security. And so the amount of improvement or room to improve that we have in smart contracts is vast. Now, does that mean that every single smart contract has had a security problem? No, not at all. But given the vast number that we've had deployed, we have had a sizable number of vulnerabilities. This doesn't, to me, indicate a problem with smart contracts themselves, but instead serves to illustrate where we are in the state of Web3 and DeFi development, that more iteration needs to take place for us to get to the level of production security that we expect within traditional finance applications. So what if you reject that idea, that EVM is the future? Some people do, and it is possible that there's another way. And that would be through introducing enhanced base primitives on the blockchain level itself, before the smart contract level. This is being experimented with in ecosystems like Polkadot and Cosmos, both of which have DeFi apps hosted which are not written in the EVM compatible language, Solidity. Solidity is the language in which Ethereum virtual machine contracts are written. The alternative to this, and the one that has the most promise today, is WebAssembly. And oftentimes, WebAssembly or compatibility with WebAssembly, which is an alternative to the type of computation that we are seeing with EVM, it's also often paired with native blockchain interoperability. So in the case of Polkadot and Cosmos ecosystems, we have major enhancements in interoperability. where smart contracts are no longer needed in order to move assets between unlike chains, so long as they follow the compatibility rules of the larger ecosystem. I've had the pleasure of using these tools, and I'm pleased to report that they work extremely well. The pitfall that we're seeing is the density of DeFi applications within WebAssembly environments is significantly less than we see in EVM environments. The future may change that, though. One thing we know for sure is that when we look at all of this, blockchain and Web3 is the future of information and value. And when we think about things like the way that three-point accounting truly removes some of the worst pitfalls of the old order, and we think about what these types of things could mean for our society in terms of efficiency and innovation, we see that the future is extremely bright for blockchain. And even in its current form, its utility provides a compelling alternative to many traditional finance practices, whether that's in accounting or supply chain tracking or dozens of other areas. And we're seeing huge innovation across all of these spaces. The real question isn't when is blockchain going to become mainstream? The question is, when are you going to make blockchain and Web3 a major part of your development journey? Because I believe with all of my heart that blockchain will be the thing that takes us to the next level of human proficiency with working together, with achieving success as a species, and with taking us to a point where we can do better by every single person on the planet, as I know we all want to do. Thank you so much for this time here today to meet with you. Once again, I'm Phil, head of events at Moralis. Moralis is your partner in Web3, and we are here to help you to scale your business into the most exciting new innovation in accounting, in computation, and in business that we will see in our lifetime. If you need a partner in this journey and you need somebody to come with you and to teach you the ropes and to take you every single step of the way, Moralis is here to do exactly that. We have a wonderful academy set up that can take you from scratch, teach you how to code, and then take you right into Solidity and smart contract programming. If the business angle in blockchain is more what you're interested in, we have resources to help with that as well. And I encourage any one of you to reach out to me directly with questions you may have. It was my pleasure to speak with you today. Thank you to IBC Media for having us, and have a wonderful week.
Wow, a huge round of applause for Phil. So the temperature just went up a bit. That was quite an amazing session. We'll move on to a list of questions. Shivam, guys, feel free to ask.
So yeah, you all must be hungry now because next is lunch, you all are aware. But yeah, if you have any questions before that, feel free to ask. Just don't ask where we'll get the food coupons because that's not for me. But yeah, anything else if you guys have. Anyone? Okay, I think we are good. Everyone just wants to move out now. So yeah, Deepak, I think we are good to pass.
Thank you. I think for lunch, there is a process that we have to follow. The exit is towards the left. You have to walk around. There will be volunteers. You have to go take a right. There is a food court section. That food court section is on the first floor on that building. That physical space has a limitation of about 100 people or 120 people that people can sit and eat. But then, so the plan is you can go take pre-packaged boxes Find space there. If you do not have enough space, you can carry those boxes here, and then find space that you can eat, and come back in 30 minutes. Deepak, how long do we have the lunch? 30? Deepak is saying 45 minutes, but I would say 30 minutes because we are lagging behind. We are running short of time. We have other events to catch up. We have a live session after lunch, and please make sure that we use and make sure we don't litter around. A lot of regulations around cleanliness. So again, once you are done with the lunch, please come back again in 30 minutes, max 45 minutes, and then we can take it from there. Thank you.
What is Internet of Things? Taking anything that's not connected to the Internet and connecting back to the Internet for efficient use to ease people's life. It has the ability to make our environment smart. This provides the opportunity to the smart lives. IoT is going to be one of the biggest agents of change. We at Nitro aim to drive mass adoption of IoT. We want to make the world a smarter place. It all starts with you. A smart world where we live conscious lives, efficient lives, productive lives. We live life in a smart way. And we believe that IoT is going to be one of the biggest catalysts that makes us and everything around us smart. Right from your home to large infrastructure and everything in between. Come join us to make our world smart. Internet of Things. It is the most important innovation that is happening around us. What is Internet of Things? Taking anything that's not connected to the Internet and connecting back to the Internet for efficient use to ease people's life. It has the ability to make our environment smart. This provides the opportunity to the smart lives. IoT is going to be one of the biggest agents of change. We at Nitro aim to drive mass adoption of IoT. We want to make the world a smarter place. It all starts with you. A smart world where we live conscious lives, efficient lives, productive lives. We live life in a smart way. And we believe that IoT is going to be one of the biggest catalysts that makes us and everything around us smart. Right from your home to large infrastructure and everything in between. Come join us to make our world smart.
हेलो चेक 1 2 3 चेक अभी नहीं आ रहा देखो हेलो इसलिए ये फेडर ओपन करे तो जब आएगा चेक 1 2 चेक चेक
they have full control over it, and they can bring some challenges, and that remains quite far. Yasik, you're saying something?
I can share my screen. Wait.
Yeah, sure. Can you hear me, Seek? Guys, can you check for the audio if he's able to hear me? Guys, I think Siegfried is not able to share his screen, and please check his audio settings as well. Let's try to get this done as soon as possible. Yeah, I think some issue at the end.
All right, so I could share my screen now. Can you hear me now?
Hi, Seek. Am I audible to you?
All right, yeah. Thank you, IBC Media, for this opportunity to talk at this conference. So in this presentation, I'm going to be talking about blockchains and decentralized databases. And in this, I'm Siegfried Kamgo, researcher and events coordinator at Moralis. And today we are going to talk about the following. So our outline is going to be, firstly, I'm going to start by giving an overview of centralized databases. Then secondly, I'm going to give the problems associated with centralized databases. Then I'm going to give how blockchains and decentralized databases solve these problems. Then we are going to see how Moralis allows developers to leverage the power of blockchains and decentralized interfaces. And finally, if you have any questions, I'm going to be happy to answer them. So to begin with, what's a database in the first place? So in traditional software development, a database is simply a software to store information and structure that information in an organized way. So if you have ever used any type of software applications, like maybe Facebook or any web application in this matter, you need that information that you provide to that application needs to be stored in a database, and it needs to be stored in a very structured and organized way, so that when you try to use the application, it's going to be easy for you. It's going to provide a better user interface, and the company running the application can actually make better decisions with the information that is in that system, you know. Now let's look at an overview of centralized databases. So the first one we have what we call relational databases, And these are databases where when you want to store information that require key value pairs, you need to store them in relations. You need to put relationship between this between the data. And one of the biggest and most popular way of querying data, which is relational, is by using SQL. And if you take an example, for example, banks and financial institutions, the data stored in those databases need to be strictly relational. So you need to have key value pairs. For example, who owns what accounts, who owns what balance in the account, what balances belongs to who. And if you make a transaction, for example, you need to the database needs to be updated with the balance of your account. And so SQL is very good to store this type of relational databases. Any type of relational kind of features between the data, SQL is very good for that. The next one is we have no SQL or non-relational databases. And you can think of this type of databases as databases where you really don't need some kind of strict relationship between the data sources. And for example, if you take an AI stream of data, for example, or an AI model where data needs to come from a large streams of data, in this case, generally you don't really need some kind of relation between the data. So a database like MongoDB, for example, is going to be good for that, where you really don't need some kind of strict relationships between the data, like for example in a bank or some kind of financial institution where the data needs to be strictly relational. Yeah, so non-relational databases, you can think of examples, AI models where large streams of data needs to be accessed at live. It needs to be accessed live. The third one is graph databases, and graph databases are used mainly to store data that has kind of complex relationships. And you think about Facebook, for example, sometimes the relationship between your friends and friends of your friends, and maybe the restaurant that your friend likes, the books that your friend likes, can become very complex very quickly. And in order to store this information, a relational database might not be very efficient in doing this. An SQL database, cannot be very efficient in doing this. So you need some kind of a graph to store the information in a better, more efficient way. So next, we are going to talk about the concept of CRUD. And this is a very common concept in traditional software and databases management, where CRUD stands for create, read, update, and delete information. So in centralized databases, you can either create information, you can add information to the database, you can read information from the database, you can update information in the database, and you can delete information from that database. So, however, not every user has the same access or the same power to do this in the database. For example, not every user can read, or not every user can update the information or delete information from the database. So there's this concept of the super user, or user with more powers, who can either update the database or delete information, or just do whatever they want with the information in the database, because they have the keys and the power to do so. And this is what we are going to see next in the presentation, when I'm going to be talking about why blockchain and decentralized databases are important, because they try to solve some of these flaws that exist in CRUD, as I was talking earlier. So next, I'm going to be talking about some of the problems. We are going to see some of the problems associated with centralized databases. And one of the biggest problems is the shadow banning problem. And if you use some kind of social media platforms, like Facebook, Twitter, YouTube, for example, sometimes they can just shadow ban you. This means that you can imagine trying to post a tweet or kind of make upload a video to YouTube, and YouTube just decide not to show this information to your audience, or just decide not to show it at all. And you're going to be there thinking that your information is online, but your users can't see it. And you can remember there was this shadow banning on Twitter and Facebook with the Cambridge Analytica cases, Twitter shadow bans where people post their tweets, or maybe they can just restrict some users not from seeing it. So now you start to see how powerful centralized databases can become when it comes to restricting who can access what data at what time, you know. So this is very inefficient and very problematic, as we are going to see later. The next one is the next problem with centralized databases is a lack of transparency and integrity in the data. And a big example here is accounting fraud, because you know that most of the public companies have to publish audited frequently, and sometimes what we see is that the company can have a very big influence on the auditing company or the auditing firm that's auditing the books of this company, and they can tell the firm what to do, or they can simply change the data in the system. And who has, like, nobody has the power to verify that what they're actually putting out there is true until it has to be, you know, reviewed that there was some kind of fraud going on or something, when the position is really was. Another point is in lack of transparency and integrity, cybersecurity, because once there's lack of transparency between who has access to what data, and even within the company, sometimes you realize that not everyone has the same access to a certain type of data. And this might be good or bad, but we have seen situations where a user or like a database administrator can simply hack the database, or sometimes update the information from that database, change information, and which is going to cause a lot of like negative implications to the company, the government, or the bank, or, you know, you can think about this of any type of centralized entity where there's a single point of failure, and one person can either hack into this company, an external party, or sometimes even an internal person within that company has some kind of access to the data. They can change it, update it, delete some things, update, you know, just make some things that is going to cause negative results to the company or to the organization maintaining this database. And one of the popular news events in the news lately is the fall of FTX. And even though FTX was a crypto exchange, but they were a centralized exchange, which means that most of their dealings were not available to the public to really verify what they were doing. So they had the opportunity to really go behind doors and manipulate the activities, to use user funds to do certain things that they were not allowed to do. And unfortunately, this caused their downfall, and they went bankrupt. So in this part, we are going to see how blockchains and decentralized databases try to solve some of the problems that we mentioned earlier. And before we start, I think it's very important that we first of all define, or like remind ourselves of what a blockchain is. So as Shiv explained to you earlier, a blockchain is a database, because we are talking about databases here. But it is not any type of database. It's a decentralized database which is run by a network of nodes which is distributed all around the world, all around the globe. And these nodes have to come to consensus in order. The topic of consensus is a big topic, and, you know, it's beyond the scope of this presentation. But what you need to note here is that consensus is that algorithm that helps network participants on the blockchain to come to agreement on the state of the blockchain, to know which node is actually respecting the rules, which miner is respecting the rules. You know, there are different forms of consensus for nodes to agree on the state of the blockchain. You have proof of work, mining, proof of stake, Byzantine fork proof, and all these other consensus mechanisms. But what you need to note about consensus is that is the algorithm that helps network participants to come to the agreement on what state the blockchain should be in. Another feature of a blockchain is that there's no centralized authority, which means that there's no company, no one person that manages the blockchain. And in this case, I'm talking about centralized. I'm talking about the public blockchains, of course, where, you know, there's no company that runs the network. Network is run by decentralized a network of nodes of people. Like, everyone can run their own nodes and be participant in the network. Maybe you have heard about Bitcoin mining, for example. You can mine Bitcoin. You can verify transaction on the Bitcoin network. You have heard about proof of stake, for example, with Ethereum and other chains out there, where you can just stake your tokens and provide security and contribute to the security of that chain. So in the next part, we are going to try to compare blockchains and centralized databases. And this here we are going to see that blockchains are append only. What does this mean? Remember we talked about CRUD. In CRUD, you can either create, read, update, and delete information from the database. However, with blockchains, you can only write and read information from the database. So in the CRUD definition, with blockchains, only the C and R are maintained because you can only create information and read information from the blockchain. However, you cannot update, you cannot delete that information. So this is very good for use cases like the ones I was mentioning earlier, where there's a public good in play. Maybe there's some kind of accounting for public companies, some kind of government transparency, where you need that data to be available to everyone, so that there's no corruption going on. For example, there's no malicious activities going on with users' funds. For example, like in the case of FTX. So blockchains are append only, meaning that the information that you put on the blockchain, you can only put on information on the blockchain, and the information that you store there is stored there forever. You cannot change it, you cannot update it, you cannot delete it, you can only add information, and it is there forever. Next, we are going to talk about the advantages of using blockchains, and the pros are that the first one, it is censorship resistant. And censorship resistance basically means that no one can shut down a public blockchain, for example. And things no one person can shut down, or no central authority, no one single central authority can shut down the network. It becomes very resilient to maybe one single country or one single organization, one single person with a lot of power. I think there's this thing in the crypto space, that you cannot shut down Bitcoin, for example. However, you can shut yourself away from Bitcoin. So this is very interesting to know when talking about censorship resistance. The next advantage or next pro is that it eliminates third parties. And if you think about when you're trying to make a transaction in your day-to-day life, for example, trying to make a payment or something like that, you need to pass through some kind of third party, which when a third party is involved, it already creates some kind of a loophole in the stream of data, in the stream of, let's say you're trying to make a transfer and you have to pass through a third party. That third party now has some kind of option or power to do something along the way to that transaction. So blockchains eliminate that. Also, blockchains are anti-corruption, as we talked about earlier. With a blockchain, the data is, you put the data there, it is there forever, and it's available to everyone. So you cannot update it, you cannot delete it. So there's no way for you to corrupt that data, or because it's available for everyone to audit and see whatever you're trying to do. So yeah, blockchains are anti-corruptible, And finally, blockchains are transparent. And this is one of the biggest use cases for blockchains, because when data has to be transparent, blockchains are really good at doing that. And by transparency, everyone has access to the data. They can see it live, what's going on. And yeah, everyone has access to the same amount of information at the same time. So let's talk about control. So when talking about the differences between centralized databases and blockchains or decentralized databases, it all comes down to control. It all comes down to who has access to what information, who can add data, who can remove data. And in some cases, like the use cases for blockchain is that we want to have a fair system where everyone has access to the same amount of information. Everyone who can add data who can do it when they wanna, and no one has access to remove data with blockchain. So as you remember with centralized databases, everyone, some kind of user, like a super user or the network, the database administrator with the keys can update the data, they can change the data to suit what they want to do. However, with blockchains, you cannot do that, and everyone has the same rights, and it's more fair because yeah, everyone can see what information is there. Everyone can add data, but no one can remove data. This now brings us to, despite the fact that these blockchains are very good. However, in the current state of public blockchains, for example, with Ethereum and other big blockchains, there's a lot of inefficiencies going on right now, and one of them is the fact that blockchains are very inefficient at storing data. So if you think about NFTs, for example, you might have heard that most NFTs, the actual data of the picture, for example, or the music NFT, for example, is not actually stored on the blockchain, because if the nodes are distributed across different computers all around the world, it becomes very difficult to store some kind of large amount of information and access this information in real time. So in this case, a centralized database might be better at storing this information. That's why if you see services like services trying to create a duplicate of a Web2 application into Web3, becomes very difficult to scale, because the data needs to be nodes, different nodes needs to come to consensus at all time, and it becomes very inefficient. The next step is that the next point is that it's a bit difficult to build and manage. So, as you know, building a blockchain infrastructure is difficult. It requires a lot of time, a lot of manpower, a lot of resources to build, and sometimes it takes a lot of time. If you think about a blockchain like Ethereum, which is the second biggest blockchain by market capitalization, you realize that it's still being built. It's still very inefficient. It's still not finished. The product is not finished after 7 years of running. And this is what we talk when we say that blockchains are very difficult to build and manage. If you think about other big blockchains, like let me say Polkadot, for example, it took about 4 years just to come with the mainnet, and it's still not optimal for people to use. So blockchains infrastructures are very difficult to build, and just maintaining the network, is difficult. So that's the point. And also they are very expensive. So if you ever try to build some kind of Web3 application, you realize that just querying the data from the blockchain, just building infrastructure around it, the blockchain itself is very expensive. And sometimes you need like a whole team just to build infrastructure on how to get that data from the blockchain and make actually real use of that data. Or sometimes it takes a lot of time. And as you're going to see later, that's where Morales comes into the picture, because Morales solves most of these problems by allowing developers to leverage the power of blockchains. Because we have talked about the benefits of blockchains, but some inefficiencies exist, and a service like Morales can help you to leverage these benefits of blockchain. So Morales comes into the picture when you're trying to leverage all the benefits that blockchain offers, but you still need to maybe have all the money, as we talked about earlier. It's expensive sometimes to query data from the blockchain. It's difficult to build the infrastructure itself, difficult to manage, difficult to store this data. So Morales is a service that comes into the picture when you want to leverage and pass all these difficulties of blockchains and actually leverage all the powers that blockchain can potentially offer to your project or to your development journey. So what is Morales? Morales helps developers build faster and smarter applications with APIs that bridge the development gap between Web2 and Web3. What do we mean by this? We mean that with Morales, everything is one line of code. We have done all the work for you in such a way that if you want to access any information from the blockchain, and we support a lot of chains already. We support, Ethereum, Polygon, BNB chain, a lot of chains, and we are going to continue supporting a lot of more chains in the future. So with Morales, you don't need to you don't need to do all the work that it takes for a developer or a project to just build infrastructure around the blockchain, like getting data from the blockchain. Because as we talked earlier, blockchains might be good at making data public, but actually accessing this data and making reuse of this data is a bit more complicated than a lot of people think. So that's why services like Morales come into the game, and you can build everything with Morales using one line of code. You can get any blockchain data with a single API. If you want to get, for example, user balances, NFTs, information about what NFT the user has, you can just use one API by Morales, and you continue your life and building the features of the application. With Morales, developers can go to market in days, and according to data from our users, we have saved over 87% of development time that it takes for users. And it's not just time, it's also money, because if you want to build just a simple project, imagine you have to hire a lot of developers just to do these basic things like building infrastructure around getting data. With Morales, everything is done for you with one API that you just, you put into your application and you call that data and you continue with your life on building the features that are core to the application itself. So this brings me to the end of the presentation. Build faster, build better, build with Moralis. Thank you for listening. If you have any questions, I'll be happy to answer. And you can follow me on my social medias, Siegfried. You can write me an email. You can add me on Twitter. You can follow me. You can add me on Instagram. On Telegram, sorry, and on Discord at Cambo.e. So if you have any questions, I'll be happy to answer them.
Yeah, thank you, Siegfried. I hope my voice is audible. If not, then I think we will have Shivam and our team to send you the questions if there are. Guys, we have any questions here? Let me check again. Do we have any questions? All right. Okay. And all right, let me just check. Yeah. I guess that's about it, Shivam. I think we don't have any questions as of now. But if they do come in the meantime or maybe later on, then I guess Shivam will be able to take it. I really appreciate the fact that Siegfried could take out the time even after the delay, and we are really thankful to you. Unfortunately, you might not be able to hear the voice, but we are actually glad to have you, and it was one of the best presentations that we have had. Okay, one question that we have on Discord is what is, okay, 1 p.m. on Discord is what is your take on Polkadot? Yeah, Shivam, can you communicate with him? Thank you. Guys, can we have Siegfried back on the screen, please? Requesting the backend team to get Sig on the screen. Yeah, okay. Can we see if his mic is on so he can speak? See, can you hear us? Okay, no worries. Can he speak? Okay. No worries, we'll sort it out in a couple of seconds. Sometimes there's so many connections that some or the other things can go wrong, but we'll figure it out. The backend team, can you just check if his mic is on? If he has the access to speak? Guys, I think we are not able to hear him. Seek, sir, can you try to speak and we'll test it out if it's working now?
Can you guys hear me?
Yeah, finally. That deserves a round of applause, I guess.
Okay. Okay. So the question was, what's my take on Polkadot, right? Am I right? Yes. So Polkadot is this infrastructure, is blockchain that is trying to build a blockchain of blockchains. So it's trying to build a relay chain which other chains can connect to it, you know. And Polkadot is an interesting project because it tries to solve the problem of interoperability. So if you've been in crypto for some time, or if you get acquainted to the knowledge about cryptocurrencies, realize that there's a lot of different chains in the industry, and sometimes it becomes very difficult for someone to transfer asset or to interact between chains. So I think Polkadot and Cosmos also are trying to do something around that. They're trying to build a blockchain where it is interoperable, which means that every chain can communicate with each other through what they call the relay chain, the main chain. And I think, yeah, it's a very interesting project. And with Polkadot, you can do a lot of things. You can build different technologies. For example, you can build EVM compatible apps using their Moonbeam project that's built on Polkadot. And what I can say is that it's a very interesting project. However, it still has a long time before it comes to full maturity, in my opinion. So that's what I think. I think Polkadot is interesting to watch, but it still has a few, I don't know, maybe years before it comes to full maturity. So I guess it's
yeah,
that's the answer to it.
Thanks a lot, sir. We are also working with Polkadot to speed that up, and I'm definitely, we are looking forward to working a lot together in the coming days. Thank you for that answer. We also have another question if you would like to take, if the time permits. That is that, do you think blockchains should be regulated by governments? If I
Okay, so about regulations, I think blockchains itself, like the protocol layer of the blockchain, shouldn't be regulated, because if you think about the internet and the ICCP, you know, ITCP, TCP/IP, and all the protocols that enables the internet to be possible, those protocols are not regulated. However, the applications that run on those protocols are regulated because they are run by, you know, people which need to be regulated, companies that need to be regulated. And about blockchain regulation, I think it should be a similar application where you shouldn't regulate the protocol, but if maybe something about if people are trying to use crypto for some kind of activities in the country, you should regulate those people. You should regulate their activities. And yeah, that's what I think. I think regulation around crypto should be done on the individual level, not at the protocol level, or not on the level of the protocol itself, which is not, it doesn't make any sense.
All right, thank you so much. I think that would give our audience a little bit more clarity, and definitely if I would suggest all of you to, I mean, governance in blockchain is a huge topic, and it's a huge debate as well. And you should definitely check it out more and find more about it, and we can obviously discuss it to a long length. I mean, that would be a never-ending discussion. We really appreciate the fact that you're here, and we want to thank you once again, and extremely sorry for the delay, and we hope to see you soon again, and looking forward to work with you again. Thank you so much, sir.
All right, all right. Thank you, IBC Media. Thank you for this opportunity and the collaboration with Morales. I'm happy that I had a chance to present in this event, and see you guys in the next one.
Absolutely, sir. You too. Thank you. Come on, guys, give it up. So one interesting thing just has happened. So I want 12 or 15 students to be ready for something very exciting that is happening at another event, which is T-Hub. And a super speaker is going to be there, and we wanted to make sure that some of us can go there and enjoy that session. That would be an additional input in your overall Hackfest. You don't have to worry about the travel. We will be providing the vehicles. You will be going with us. Can I see some hands? Awesome. So, wow, guys, you are going to leave me and Shivam alone or what? Okay. Nobody is going to be dropped on their, at their home, huh? Just, is it again the same number of hands? Okay, fantastic. That's a lot of interest. Okay, let me begin with how many of you, your names start with A? Okay. Let's see. 1, 2, 3, 4, 5, 6, 7. Okay. Let me do this. That's a logical question. Let me do something else. So, okay, fine. Since I already started, I'll give this. So, all of you guys who raised your hand, whose names are with A. Okay, we'll be checking it with your Aadhaar card. Huh? Don't worry about it. All right, so come on, guys, get up. I would request you to, just go and wait at the lobby, and we'll provide the vehicles for you for this event. This is a huge speaker session that is from Polkadot itself, which is our largest community, which is why we are doing this Hackfest. So I want you all to. Okay, are we going? Yeah. So we can get up. You can go to the lobby right away. I think 7 or 8 hands I saw over there, right? Is anyone interested to go from that side? Yeah, just give me a second. Yeah, perfect. So, yeah, please go to the lobby and we'll provide the vehicles. Okay, no, don't be smart. I might have to check the Aadhaar. Let's not do that. Let's not go there. I saw 7 hands. And coming to this lady's, so give me an alphabet, not your name. It's okay, let her give it. Not your name, not your name's alphabet. Give me a random. R, okay, so now I'll come here. R, who has R? Okay, 1, 2, 3. Okay, 3 of you. Okay, I think that's about 10. And we will take a few more. How many can we? All right, okay, fine, just because it became quite fun, so I'll add a little more, like let's say 10 more students. So we are done with R. Please go to the lobby, don't leave the premises. You have to go in our own vehicles. Our vehicles that we'll be providing. When do you, we have the similar timeline, just like this project. It won't be late, don't worry about it. T-Hub, nearby, yeah. Huh? No, the policy is strictly applied. Huh? No, there's no star mark in that. Okay, so 10 more. Give me an alphabet. Z, who has Z over here? Oh, amazing. You can go up, 2 of you. All right, so 8 more. Okay, easy, let's go with okay. Guys, okay, I'm tired of this. All of you might end up leaving. Let's do one thing. The last row over there, if you want to go, Avinash sir over here will guide you, standing right at back. You have so many problems. So in the next session, we'll try to mix it up. We'll change seats or something. Dhruv, come here once. Is anyone here, seeing so many people ready to go, is anyone here, if anyone here has come by their own car? No, right? Okay, she is there. Would you be interested to go to T-Hub? Would you mind accommodating 4 students with you? No problem? Oh, okay. First I thought, no, you don't want to do that. Okay, really appreciate it. Thank you so much. Please follow Avinash sir with you. Yeah, you can drive along with him. Yeah, that would be great. Ah, amazing, no? You have your own car, right? I mean, over here, not at home. Over here? Perfect. Thank you so much. Would you mind accommodating 4 people with you? Will that be okay? Perfect. Please follow Avinash sir. I think that's about it. Yeah, sure. It's totally up to you. Yeah. I mean, that much choice I can give. You can choose your people, who you want to go. Yeah, absolutely. Okay, guys, okay, it's not going to be boring over here, huh? So don't worry about it. We'll try to match up the speaker over there. Okay, we'll just wait another minute to get this all sorted. Yours is the second last session, and then there is another session that is also. Hotspot का password क्या है? 147 HE 6 times L. HE 6 times L. L. It's okay. It's connected. क्या है मेरा crowdy गायब हो गया यार सर. कोई नहीं, मैं तेरे लिए एक और करवा दूँगा. नहीं अब बस मैं ड्रेन हो जाऊँ उसका. Have the students there who are going? Okay, you were going, right? Yeah. Okay. Right, yeah. I really appreciate the fact that you take the initiative, to help us and yourselves. That rallies quite a lot. Perfect. So we'll give them 30 seconds. 30 seconds to a minute. Then we'll get back to our rock star over here, Mr. Shivam, with his session, which will be his last session, and hopefully not the last session with us. Obviously, overall, we would love to have him again. Right? We would love to have him again, right? Okay, give him a little bit more cheer. No, he'll leave tomorrow. He came here for you all. Perfect. Amazing. I am sure he might end up staying more. He might cancel his meetings. All right, so I don't need to introduce Shivam to you. And generally, I would speak a few pointers about the next topic, but I don't really think you want to listen from me when you have Shivam over here. So I will let him introduce and start. Ready? Perfect, thank you. I'll just take a call on mine. Yeah, sure. Okay, Shivam, I think the presentation is private. I think the presentation is private.
We can't display this presentation. It might have been. Oh, that was not the case. Let me just share it.
Yeah, sure.
I just WhatsApp the link.
Its WhatsApp is not there.
Okay. Whose laptop is this?
I don't know. This
Motherfucker, then I can't do this.
company's laptop.
So how do we do it? Can you display it from inside?
But this will not work from inside.
So what's the best way?
You should give access to this. నవాజ్ భాయ్ ఇది హ్యాండ్ మైక్ హెడ్ఫోన్స్ పనిచేయదు.
The label mic. The label mic. Shivam, I don't have it. I don't have it. Yeah, got it now. Let me just log in on.
No, we got it.
You got it on mail?
It on mail.
Perfect. Streaming?
That presentation, right?
Oh no, that's a different link. Yeah. See the main audience. No, I'm just saying that main audience is ours. Fourth year. Is there a fifth year? No? Okay. Okay, that is for the people who don't complete the fourth year, right?
Working.
Let me try to log in on the WhatsApp. Chrome is, torture. It's not working, man. No, it's not working. And they are like living in some other generation. No, I think that's the issue of Chrome. I think so. I'm just trying my hand. So guys, there's some issue with the presentation. So what we'll be doing is Shivam will obviously run you through without that presentation, and we will share that presentation with you later on. That works? Yeah, okay, fine. So we can begin. All right, so this is Shivam's last session, and let's give him a round of applause.
Perfect. We had some. Okay. Yep, we had some technical glitches, and this talk is like you have nothing to see there. It's just the same human being again for the third time. So yeah, let's just talk about important functional use cases of DeFi. And just before we start this, actually, I wanted to share a surprise. Like for most of the people who had cars and those whose names start from A, B, N, C, and whatever it was, like they moved out. But then I thought, like, who is staying here? We should probably share something special with them. So yep, I have a special access to one of the new things that we are building. We just turn it on sometimes when we want to share about it, and we just keep it off. So I've just turned it on. I'll share it with you guys. You can forward the links, but it won't work for most of the time because we'll switch it off. So it's just for you guys. But yeah, we'll go to that at the end, and let's just get started with what's basically DeFi. So you guys cannot see the, obviously you cannot see the presentation, but yeah, DeFi is not just when moon, right? Most of you guys might have heard about DeFi when we had the DeFi summer last year, right? Like every DeFi project, every DeFi crypto was mooning a lot, and everyone is like, just buy any random DeFi coin and that's gonna moon. So that's not exactly DeFi. So DeFi is like doing finance in a decentralized way, right? Let's take a very simple example of lenders, right? Let's say I want to lend out some money to any of you guys in hope that I'll get back 10 to 12% or whatever is the agreeable return on the money that I lend you, right? So the options that I have at this moment is I can go to a bank, or I can go to any other central entity. I can go to NBFCs or something like that. I can partner with them. I can give them a huge lot of money, and then they could distribute it to like individual people, and based on that I can get some interest, right? Or I can put it in the bank, and bank does the same, right? When you put your money in bank in the savings account and stuff, I'm just not sharing any leaks here, but let's say if every one of us just go to bank and ask for the money that we have deposited, banks never have that because they use it to lend out to other people, right? So that's the traditional centralized financial system. There's a lot of loopholes and a lot of problems in that, which I wanted to share. So first one is need to trust. Let's say I'm 100% sure we're never gonna face it, like never gonna face that type of situation. But let's say if everyone in our country needs to take out their money immediately from the bank, there's some untrust issues or something like that. That's never gonna happen with India, 110% sure. Like we'll be the last country in the world if that ever happens to the world. So yeah, but let's say if there's something like that, then you're basically stuck there, right? And let's also take the example of some of the fraudulent activities that have happened around the banking system. So you might have heard a lot of scams that have happened to banks and stuff. But eventually when banks lose money, or let's say the people we trust, we are giving our money to, if they lose that money, it's us who are losing, right? It's not money that has come from the thin air. When you deposit a lot of money in the bank, they give out loans to someone who just like defaults the loan or something like that. Either they fulfill it from their profits, or most of the time which happens is like government, you could say, pulls them out of that specific situation, right? And how does the government get money? It gets from us, right? Like we pay the taxes, government has its own businesses and stuff, but yeah, eventually it's people's money that gets lost. So the thing is, in the current centralized finance model, there is a big problem, which is trust, as I shared. And the next thing is a lot of manual dependency. So let's take very simple example of lending, right? Like I lend my money, but let's say if someone wants to borrow some money for their marriage, or maybe they want to go to maybe they want to come to Hyderabad to give a talk or something, and they want some loan for that. So if they go and ask bank for this specific startups that are coming up, which evaluate your credit score and give you an instant loan. But for most of the population, it's not directly accessible, right? And it still comes into that trust kind of chamber where you have to trust them and all that stuff. So there's a lot of manual dependency that we can see in here. Next problem is huge processing time, right? If you go and take out a loan, even from the fastest NBFC, I'm not even talking about the banks, even the NBFC, it at least takes 10 to 15 minutes to process it. But let's say if you are on blockchain, right, and if you have some assets that you want to back and take some loans, it basically takes a minute or so. But yeah, we'll see that more. And yeah, current CFI system is very costly as well. We saw this in the first talk when we were discussing about introduction to blockchain. So it's not exactly because how CFI systems are technologically made, it's because of the system that's built around that technology, right? Like sending money to US should not be a problem. Let's say if the whole world had just one bank account, then sending to money to US or someone would be just like a UPI transfer, right? Technologically, it's possible if everyone in the whole world is just on the same bank or something like that. But we are not structured that way in the world, right? In the whole geopolitical world. So what happens is you raise a request to send the money, and as I shared, like our Indian bank connects with the American banks and so many things. So it just increases the cost drastically because there's many other parties involved as well, right? If they're fostering your transaction, they want something for that as well. So it becomes costly there, and yeah, it's very vulnerable. So there are a lot of hacks that could happen around it. Like you might have heard about like UPI scams and all of these, but I'm not talking about these because these are basically human errors. It's not exactly technological fault, but it's a human error. But you might have heard that sometimes your UPI network is down or something like that, right? That's not exactly human error. That's technological problem that we have sometimes. So they're vulnerable to these problems. And yeah, in CFI, basically you hold nothing. It's like if I just ask you how much do you hold and how much do you control in your wallet right now, the cash that you have is something that you could say. And apart from that, let's say if you just show me your account balance on any random UPI app, you could say that you control it, you can send and transfer it, but you are not the only one who could control it. Basically, there is third entity involved in as well, right? And you can be barred to spend. So centralized entities can anytime just ban you to spend at some specific entities. I'm not questioning why they ban, is it good or not and all that. We're just talking about the fundamentals, right? It can happen. It doesn't depend, I'm not talking whether governments do it for the correct purpose and all that. And that's a whole different topic, and I'm not perfectly, you could say, eligible to talk on that, right? But yeah, there is a possibility in that, and mostly you would like to have the most ideal system, right? And having this power with someone who could just freeze your money and then you cannot just spend it anywhere, it's not cool, right? And yeah, last problem that I wanted to share with CFI is you always need an intermediary, right? Even when you just pay at, let's say, I had a bad example, but let's say you want to pay at a cold drink shop, right? So if you just scan and pay there or do whatever, there's UPI involved in it. Like you need a centralized entity always in between. So yeah, DeFi removes all of these problems, right? And there's a lot of use cases that can be built around it. And one of those is insurance, which we have discussed earlier in the talk as well. That's why I just wanted to bring it up again. So insurance could be really made more close to humans. Like it could really improve the user experience. Currently, people are so much afraid to claim an insurance. They're like, okay, I have to go through hundreds of processes and all that. And even if we simplify it to bare minimum, it doesn't actually come to the state where we can call it like, yeah, it's ideal. What would be ideal here? Ideal would be the smart contracts that we discussed, right? Like, let's say if something happens, something is confirmed, then nothing stop you. Like, you get your insurance claim or something like that just in minutes, right? And yeah, next use case, which is one of my favorites use case, is derivatives. Like, you can literally derive any basically financial, you could say financial token or maybe financial asset of the world and bring it on DeFi, right? Let's say currently most of the world is interested in investing in India and some other countries like Indonesia because we are growing very fast, right? But if if a traditional institute in US has to invest in these countries, right? There's so much of process of registering and all that stuff. But what if we could just make a derivative of, let's take any random stock. I'm not sure if I should take the name of the stock, but let's say XYZ. So if I just make a peg of XYZ and like have a derivative token of that on a DeFi chain, then basically anyone in this world can just create a normal Web3 wallet and just access it, right? And trade it around. So that's one use case. And also it has easy on-chain verifiability, right? Like let's say you want to file taxes, or let's say if, let's say in some time of the world, probably if Web3 is going to be massively adopted and everyone is going to collaborate, then definitely government should know how much you're spending and what you're doing and what you're not, right? Then probably there will be a solution which will identify, okay, Deepak has this specific wallet, and if I need to verify whether he's paying correct taxes or not, I just see for all the transactions on that wallet and calculate, right? So it's easy to verify that on chain instead of the current CeFi system, right? And yeah, another use case of DeFi is easy asset management, right? Like currently, if I have to write down all the assets that I hold and all the profits and loss, that will be a big headache for me. Because I have something in stock market, I have something in crypto, I have something in mutual funds, I have something on this broker, on that broker, and if I have to do all that, it becomes kind of a pain. And in a decentralized world, you just know the wallet that you have used, and you can basically see all the, you can basically track all the assets that you have and see all the assets that you hold, right? And the surprise that I wanted to share is somewhat related to this as well. So yeah, just a hint, but yeah. Next use case of DeFi is trustless lending and borrowing, as I shared earlier, right? I need not to trust anyone. Let's say if I'm in a DeFi ecosystem where I made a smart contract, I'm giving away, let's say, 1 Dogecoin to all of you, and you all pay 10% interest on that. If that's on a smart contract, I need not to go and ask anyone. Like it's there on the smart contract. Like code is the law, as we say in Web3. So once the tenure of the loan gets over, I'll automatically be credited with your 1.10 Doge with the 10% interest, whatever I expected, right? So yeah, easy lending and borrowing, and then yeah, easy credit access status. Like currently, if I have to build an NBFC or something like that, I need approval from RBI, I need a lot of licenses, I need to get access to your credit score to verify whether you are credit worthy or not to lend out money or not. And there's a lot of stuff. But let's say if I want to do the similar thing on Web3, like on blockchain. So I can just get all of your financial transactions, all of your holdings and everything on chain just in 1 minute. And that's also something that you would be able to do with the surprise product that I'll share you at the end. But yeah, before going into that surprise, one last use case and very important use case of DeFi is staking actually. So you can stake into projects, you can contribute to projects that you like. Like let's say you like Ethereum, you can contribute to Ethereum by staking your ETH, and that will help to validify transactions, right? And that will also give you easy access to the new projects instead of like how you would do in the traditional. Let's say I build my startup, and if you want to invest in my startup, you cannot come and like, okay, I have 500 rupees, I want to invest in your startup. That won't work because like there's so many process around it. I have to give you some equity and all that stuff. But let's say if I just have a blockchain as a project, or let's say if I have any normal Web3 project, right, where I want you to stake some token, and instead of that, I promise you some reward or something like that. Actually, not just promise, I deliver you some rewards or like that in my own token, then you get it, right? It's quite easy to access there. And yeah, talking about the last thing, building these DeFi apps, right? So I'm quite sure from tomorrow, most of you guys will start thinking about these ideas. Like I'll probably give this as a task. Like once you go back home today, think what Web3 is, what blockchain is, like use IBC's Discord as much as possible. Like Deepak shared, he sleeps around 3 or 4 o'clock in the morning. So no need to worry, just ping him, tag him, bug him on the Discord. Like, okay, I have this doubt. He'll get it clear. And make sure you understand whatever we have discussed today, and you come up with an idea that you can pursue. Because, you know, like, I'm quite sure you're mostly in first, second, and third years, right? We are not having anyone from final year, do we? Yep. So not much as well, but let me just first tell what I was sharing for the first 3 years of the students, right? So you still have at least a year to leave college and get into placement and whatever and whatnot, right? So you can now start experimenting, building real projects and executing on the ideas, because that will really help you to show to a recruiter what you have been doing in your universities, apart from getting 9 CGPA and 10 CGPAs, right? And even if you are in final year of your college, right, it's really important and great to share what you have built when you are going to sit for the recruitment, right? Like you may not have as much time as the first, second and third year guys have. They probably have more than at least 6 months before recruitment. But you still have enough time while you are here in the 9-day Hackfest. So think of the idea that you want to work on and get started on it. And yeah, while you're getting started on it, I would like to share some more brief about us. Let's say you plan to build a digital wallet, or let's say you want to build, you plan to build any specific dApp for gaming, right? Let's say you want to basically build Dream 11 of Web3 or something like that. So for that, you'll probably need to get all the on-chain data and stuff around it, right? And Morales API can really help you with that. So if you go with the traditional method, right, like using the nodes, so you would have to get a node provider's, basically get a node provider, and with the help of the node provider, you will get all the data, you will index it, and there'll be a lot of problems around it. And that's definitely not the best way to go about it, right? We're also working on Polkadot with this, shout out to them, and they are also soon going to be onboarded within our ecosystem. So it's like basically you could query any blockchain data on these specific chain. I think we are working with one of the parachains of Polkadot, which we are not exactly like open to share at this moment, but yeah, soon we'll have the support for them as well. And you could basically build a dApp which is cross-chain with Morales. You don't have to worry about whether it's on Ethereum, on Solana, or Polkadot or anything, right? So yeah, that's what I wanted to share. You could do that. And I had a link which I wanted to share. I'm not sure how I could share that specific QR code, but just reach out to me on my desk and I can show you that for that specific product. And yeah, this was all from me. If you want to connect, just search Product Shiv on Twitter or Instagram and you can find me there. And yeah, if you have any questions, feel free to drop me there, or maybe just ask in the Discord as well. We'll have more mentors there to share. So thank you for your time and have great productive time ahead in the 9 days of Hackfest. Thank you.
So Shivam was leaving us without answering any questions, so I thought we'll just ask him to wait and figure some things out.
Yeah, he just told me that it's illegal. So just let me know if you guys have any quick questions we can go through. And yeah, I'll be here after some time as well. So we have a great session by Dhruv. You could attend that. And maybe if you have questions, we could answer it after that session as well. But if you guys have any questions, any quick questions? Nope, we're all good. Yep. Yeah, that will be in my desk. I'll just share that. Perfect. Anything else? Decentralized finance. Yeah, it's like centralized finance. Yeah, what? Yeah, CFI is centralized finance. So actually, I'll just give you a brief about the surprise that I wanted to share. So as Siegfried also talked about the recent FTX saga, right? Like FTX was a centralized exchange. They were not properly audited. They had a lot of crypto that they were trading, and they were losing basically a lot of customers' money, right? So it's really important that you hold your crypto, because just like in traditional finance, right, your money rests with bank, right? We don't want that in crypto, because that's the whole purpose, right? I just talked the whole day about how you could hold your own crypto, how you could have the ownership of the tokens or anything that you hold, right? It doesn't make sense if that happens through a centralized exchange, because eventually then you are just going through them. You could still use centralized exchange, but that should be just for quick tradings and stuff. So most of the time it should rest in your own hard wallet or cold wallet. We'll probably share more about it later. Maybe I'm quite sure like the next speakers will be talking about it. So yeah, the product will be like Morales Money, which we are working on. I'll share you the link soon. You could sign up to be a beta, and we are just for the IBC students who are in this talk. Like, so just let me know if you want to get the access. And yeah, if you have any more questions after Dhruv sessions, reach out to me on my desk. I'll just have a quick meeting and come. Thank you.
Thank you, Shivam. So what we'll do is, yeah, we really appreciate it. I know students want to clap for you all the time. So, all right, amazing. So why don't we give it a couple of minutes if you want to go and check out the surprise that Shivam has, maybe, you can do it right away. Let's give it like 5 to 10 minutes. Yeah, 5 to 10 minutes. You can check out Shivam's surprise at his desk. He's sitting right here in the front row. And then we'll start with the next session in, let's say, 10 minutes. Thank you, guys.
ऑफलाइन सेव कर लेता स्लाइड्स को किसको अरे वो ऑफलाइन का नहीं, वो बोला कि लिंक ही डालो, तो लिंक कभी भी दूं मैं। कैसे कैसे करूँ वो, बाकी सब ने pitch.com वाले कब से देके रखे थे। हाँ मैंने गूगल स्लाइड तो हो गया था शायद फ्री, वो बोला कि शीट पर डालो, ये डालो, वो करो वो करो, तब तक हुआ ही नहीं फिर। दो तीन दिन से गूगल स्लाइड पे बना लिया, अब कैसे चेंज करूँ मैं।
Guys, handle with care that laptop. Shivam has given me the responsibility to take care of it. So what was the surprise? Google form? Form. Was it worth it? Don't say that. Every information is worth it. Every knowledge is worth it. Requesting the team to put on the screen of the presentation here. Thank you. So now we are moving towards the last session. Has it been a long day? Yeah. Has it been an informative day? Okay. Did you enjoy the information? Awesome. I hope all of you will be finishing the entire session with the Hackfest. Yeah. That's when the actual knowledge is going to flow, especially from 26th onwards when you'll start building. You will be hearing again from another expert who is sitting right with us, Mr. C. Selvaraju, and his sessions will be also coming up. So yeah, stay tuned and you'll have to come up. So yeah, before we move to the last session, let me just introduce the topic. The topic is blockchain platforms landscape. So over the years, several blockchain platforms have come up which are trying to solve some or the other problem in a different and a unique way. Example, L1 issues brought in L2, and some changed the L1 dynamics to solve the problems existing in N1. So, I mean, obviously these are jargons, and to speak in detail so that you can understand it in much better way, we have our next expert, Mr. Dhruv Somaiya. So basically, Dhruv is a friend, an expert, and he might look young, but he started even early into this space. So there's a lot to learn from him, and I'm sure you will enjoy his session. So let's welcome him with a huge round of applause.
Thank you everyone. So just Deepak said I might look young because I am young. All right, don't get me wrong. So first of all, it was a fun session, long day. You all didn't go to T-Hub. If you're feeling bad, what I'm going to do is recap the entire day for you for free. whatever we went through, bits and pieces here and there. So it's more like a journey. We'll take a history lesson right here. Going to be very interesting. So we'll be traveling back in time, 2009, so when it all started. So, right. Probably heard this a few times. I'm going to do this again. So October 2009, what happened? Satoshi Nakamoto published the white paper for Bitcoin. Do we know who he is? Not yet. So this is one big source of conspiracy theories. So you guys are free to guess who Satoshi Nakamoto is. Moving on. So it was the first decentralized cryptocurrency that came into existence. It's a peer-to-peer system where all transactions are verified and recorded on a public distributed ledger. So that basically means blockchain. So Bitcoin is when blockchain technology really got popular, it got to the masses. So Bitcoin network also keeps all transactions public while maintaining privacy of the users, making the system trustless. So the word trustless, is it a bad word? No. Trustless, untrustworthy, two completely separate things. So trustless basically means you don't have to trust any single particular party to get the job done. So history has been proof in past few of the economic issues that we've seen. It all boils down to we trusted a few institutions to do something, and we trusted some people to get something done, and well, it didn't work out that well. So trustless is the way to go. We're moving towards a trustless world. So you can see how we can retain the privacy. Identities are separate in the new privacy model, while all the transactions are there in a public platform. So you can see who's sending what money, but there's no identities linked to it. So that's basically how Bitcoin manages privacy. All right, so this is proof of work. This is what Bitcoin uses to verify transactions. Now I'm pretty sure you guys are developers. I'm not a developer. So you probably know better on how proof of work works. But yeah, this is how we mine BTC. Proof of work is what is used. It's more like a race competition where people solve the transactions, they verify transactions, and they get rewarded with Bitcoin in the end. So starting off very basic. And after Bitcoin, we saw a lot of other cryptocurrencies come into the spotlight because it revolutionized, it made blockchain technology very popular. So we had Ripple, which basically tried to replace the SWIFT banking system. We had Stellar Lumens, we had Litecoin. So Litecoin is very, very close to Bitcoin, but uses less energy apparently. So. But there was a question after blockchain got popular, can we do more? So of course we can. So that's when Ethereum enters the picture. We've got Vitalik Buterin, who's the founder of Ethereum. Now we know who the founder is. 6 years later, after Bitcoin was launched, Ethereum came into existence. And we have a lot more functionality in Ethereum. So first things first, we got layers. So now you can have layers in Bitcoin too. We have the Lightning Network enabling us to do so. But Ethereum has the layer system you can build on top of Ethereum. So this was something very new back in the day when Ethereum came in. So you can see here, we can either directly have dApps on the Ethereum network, or Polygon is built on top of Ethereum, which is L2. And you can also have dApps on Polygon. So this was something very new that had come into existence, layers. So building on top of Bitcoin wasn't a thing when Bitcoin was initially launched. So this also was started by Ethereum. We can give them the credit. Smart contracts. So I think we've been talking about smart contracts a lot lately. Are you bored? If yes, let me know. I'm not going to skip this slide. Yeah, I've put 15 minutes into making this slide. I'm going to say it. All right? So good old blockchain technology now has more functionality. Smart contracts come into existence. So you can see how over here, again, talking about trustless, this is how you go trustless. So there is no third-party involvement. It's you want to get something done if a certain condition is met, that's when smart contracts come to the rescue. So trustless model, there are no third parties involved. So as Shivam mentioned before in his talk, so no third parties. So yeah, it's more efficient towards the end. Now, DeFi, follow up to Shivam's session again. So I told you this is going to be a revision. So this is how the traditional finance system looks like. So we've got lenders, we've got borrowers, we've got stock exchanges, we have derivatives, insurance. So all of these different financial instruments, again, most of them work on trust. All right. So moving to DeFi, what exactly changed? It's a big leap. So existing financial instruments could be converted into decentralized financial instruments. So everything that runs in the financial ecosystem on trust can be trustless. So Aave is a decentralized lender. DYDX, if this is calculus, by the way, it's called derivatives. So that's why it's for derivatives. It's a financial instrument. So DYDX does the job by decentralizing the whole derivatives financial instrument. One of the most revolutionary things that has come up is pools, lending pools, and one of the biggest players is Uniswap. So these pools are called liquidity pools too, LPs as popularly known. So I would like to say that they made a new financial instrument while trying to create a decentralized exchange. So the initial idea was to make an exchange which is decentralized, just how I've mentioned, a decentralized stock exchange. That was the initial idea, but it turned into a completely new financial instrument. So this is very interesting on how a DEX works. So me being more of a financial guy, no code here. I'm just gonna, so this is, while we're at TechM, so this is the stock ticker for Tech Mahindra. Thought it was a good idea to show that. This is the order book. So on the left side, you see a centralized exchange. That is National Stock Exchange, by the way. That's on NSE. So the shares of Tech Mahindra on NSE are being traded here. And on the blue, which you see are all the buy side, people who want to buy Tech Mahindra. You see the number, it's around 200,000 shares over here, and on the red side, it's a sell. So how this works is basically when you go to a centralized stock exchange, you are buying shares from a real person in front of you, or you are selling shares to a real person who's ready to buy from you. So there's always someone involved. Your orders go to a centralized stock exchange. They match your orders. And when the price matches, you can either sell your shares, you can buy your shares. Now, coming to liquidity pools, none of that is required. So basically what you do is, these pools usually are in pairs, in fixed pairs. So over here you can see it's WBTC, which is wrapped Bitcoin, and Ethereum. So this pool consists of two and only two assets. That's wrapped Bitcoin and Ethereum. So over here you can see the pool has locked tokens inside. So WBTC, we have around 3,500 Bitcoins and about 82,000 Ethers inside this pool. So the idea is people who need either one assets and they own one assets. Let's say I own Ethereum and I want Bitcoin, I need to switch. So I don't have to wait to go to a centralized stock exchange, send my order, and someone wants to buy my Bitcoin at that price and give me Ethereum in return. What I do is I go to the pool, I basically swap my Ethereum for Bitcoin or vice versa. So this is where it gets interesting. Where does the Bitcoin come from? Where does the Ethereum come from inside? So you see total value locked is $144 million. So where does it come from? Now the beauty is you can earn some interest if you have some assets lying around. If you, let's say you are a Bitcoin investor and you need to earn some interest, it's just sitting in your wallet. What you do is you go to one of these liquidity pools and you give them your Bitcoin to keep for a while. And they will give you interest, because as a buyer, when I come to this pool and I instantly, because I'm getting the benefit of not waiting, when I instantly swap my Bitcoin for Ethereum or vice versa, I pay a certain fees. So a certain part of that fees you people can get if you stake the process is called staking, by the way. So this is LP staking. In some cases, the pools issue something called LP tokens, which is liquidity pool tokens. So those tokens also yield you a lot of interest depending on what kind of pair you own and what tokens you own. So this was a true breakthrough technology when it comes to exchanges. Now, non-fungible future. Now, how many of you are familiar with these weird pictures? What do you see on the screen? Are you familiar with this? Did you ever buy into the hype? Yes or no? Have you ever wondered why? Okay, in fact, revised question. How much do you think that monkey is worth? No, not 100. No. Yeah, a few $1 million. It keeps fluctuating. The crypto market is volatile that way. So the price is fixed in ethers. So it's fluctuating between a few $1 million. All of these NFTs are $1 million NFTs. And they are pictures you can keep in your phone. Cat, monkey, and cyberpunks. So why can't I screenshot? Let's say you buy an NFT for $1 million. Why can't I screenshot and keep it in my phone? We've got the same picture. So here's where your smart contracts again come into picture. So I think it's called ERC 721. That's a standard on Ethereum. That's how you store very, very unique assets on the blockchain. So non-fungible, as the name suggests, basically you cannot subdivide these things. So these monkeys are always going to be in the same form. Like your Ethereum can be, again, back in the last example, you can go to a pool, you can subdivide it into something else. This monkey is always going to be a monkey. You can't make it into a dog. So yeah, what Bored Ape Yacht Club, which is the first monkey picture, what they do is they put these ridiculous price tags on these NFTs because they are one of one. So that's how we justify the prices, because they are very unique, they are one of one. And a lot of these have utilities which we might not know about. So for example, if you guys did not know, the $1 million monkey does look like hype, but it can get you into the finest parties in Los Angeles or Miami, because right when you purchase this monkey, you will get a Discord link. Join our Discord, by the way. You'll get a Discord link to become a part of the Bored Ape Yacht Club, which is the very, very exclusive club. So you'll find people like Post Malone and Snoop Dogg and a lot of celebrities to be a part of the club. So that is one hidden utility what Bored Ape Yacht Club has. So exploring more and more utilities, we've had, you see this house, it's worth $175,000. That is a reasonably expensive house. But this house also exists as an NFT. It's not just a house. So a few weeks ago, this happened actually. So this house was sold as an NFT. The proof of ownership for this house was not on a piece of paper, was not on a stamp paper by the government. It was on a NFT. So this transaction actually happened somewhere in America, where this house was basically transferred to someone else using an NFT. So, and this is also the NFT, by the way. This is what it looks like. Now, speaking of Ethereum, gas, it's expensive. Gas generally is also very expensive, must say. So on some instances, Ethereum gas fees had gone up to $150 for a transaction worth $10. Like it was a very rare case, but there have been times when this has happened. So just how Shivam explained, basically, when there's a lot of congestion happening, transactions don't go through very quickly, and hence we see the spike in the fees. So something had to be done, because one of the primary and one of the only smart contract platforms was getting very expensive. And how do we deal with it? So got us thinking. Next up, blockchain dilemma. I'm pretty sure you guys just saw a few hours ago what this is. So basically what this means is that you cannot achieve all three at once. If you try to achieve two, you will end up compromising on either one of these features. These are all defining features of a blockchain, by the way. So you can have something like Binance Smart Chain, which is not decentralized, but very scalable. It's very secure. Or you can have something like Monero, which is not scalable that much, Monero, but it's very, very decentralized. It's very private. It's basically, if you do transactions on Monero, they can't track you down. So nice try, FBI. So new era, Ethereum replacements. So this became a market trend where people were like, can we replace Ethereum? Can we have something new? Can we have something more affordable to get transactions done? So enter Cardano, we have Solana, we have Binance Smart Chain. All of these are platforms which were trying to replace Ethereum. Now, I personally don't believe there's something called Ethereum replacement. Ethereum is Ethereum, Binance is Binance. Every chain has its own unique feature and has its own unique consensus mechanism. So Solana is also very unique, uses proof of history. So it actually has a clock which helps maintain consensus for Solana. So coming to Polkadot, I think, again, not financial advice, but if I was to tell you something which is actually solving this problem would be Polkadot. So it's a layer 0 blockchain. If you look at Ethereum, it's a layer 1 blockchain. So Polkadot is very unique in itself. It's actually a blockchain of blockchains, what they're trying to do with Polkadot. It's a blockchain of different blockchains. Some of the key features would be interoperability. So cross-chain transactions are very common now. We have bridges for Ethereum, Avalanche. But the limitation is you can only transfer tokens when it comes to other chains and bridges. Mainly when we're talking about interoperability, it's only tokens. Polkadot, you can have interoperability for data types and a lot of other things. There is easy blockchain innovation, so making a customized blockchain on Polkadot is cakewalk. If you are very familiar with Substrate, you get used to Substrate, I'm pretty sure you can do this on your own, easy blockchain innovation. So customizable, very customizable. And it's energy efficient. So one big problem that we did see with Ethereum and Bitcoin both is last year, I'm pretty sure you are all familiar with Elon Musk playing this game with Bitcoin. When he was like, Tesla is going to accept Bitcoin, and then he stopped accepting Bitcoin. Same thing happened to Ethereum. In the white paper, Ethereum was originally always meant to be a proof of stake cryptocurrency, but they were on proof of work for quite a while, until September, in fact. So proof of work was now turned into proof of stake. This is basically what the ETH 2.0 merge was all about. So few statistics to back why and what changed in the ETH merge is that the amount of Ethereum tokens now being issued is quite less. So let's say if we were on proof of work, from the time the merge happened till today, we would have issued a few million tokens of ETH. Now it's in a few thousands. So demand, supply, you get the deal. So yeah, Polkadot is energy efficient. It's also user driven. So you can have a say in the decisions being made, all the changes that are being made in the Polkadot network. You have a say. So you can go to the platform. You can actually, I highly recommend you guys check out Polkadot's website. It's called polkadot.network. So you'll be able to learn a lot more on what this layer 0 blockchain is. Now, coming to the end of it, I think this is what I would call Web 3. After speaking of so much decentralization, trustlessness, and whatnot. So what is the dream all about? The dream is a new internet. When the internet was started, we could only read stuff. So you could probably go to Wikipedia and read about a certain type of a car or a place. Web 2 was when we could interact with a lot of pages. We have web apps, we can play games on the internet, we can do a lot on the internet. When it comes to Web 3, after going through all of this decentralization and trustlessness, I think what really highlights Web 3 is that you have ownership. So the highlight for Web 3 and a new internet would be more ownership over your own data. You get a say in who accesses what and how it's being shared, which right now we currently don't. I'm pretty sure most of us are on Instagram or Twitter or something. So do you think you can control what Instagram does with your personal data? You cannot. You simply cannot. So that's the dream. That's Web3 for you in a nutshell after going through the whole decentralization knowledge for the 5th time today, I guess. So to sum it up, I would say this is what Web3 is. It would be more ownership over your own data. That's all from my side. Thank you.
So guys, do we have any questions here?
Oh yeah, feel free. Ask
Can
away.
we please put on the lights? Yeah, thank you. Yeah, any question? Okay, so when Dhruv was talking about trust and trustless, I was thinking about like a few years back in college. So example, I was thinking about how if our parents started using blockchain and trustless logic with respect to giving us gifts and those incentives if we score good in college, how will it look like? So here's what might happen. So let's say your parents will put in the money. Let's say your father or mother, told you that they will give you 2 or 3 lakh rupees or 2-3 lakh rupee laptop or a super costly mobile phone if you were to get 90% in your exams. Here's how that will happen in blockchain world. Imagine parents using that logic. Your parents will put in the money for transaction in a smart contract under a condition that you get a 90%. You get 90% in your exams. And then obviously once the data is out, you get 90%, that money will automatically go to you. So end of story. Later on your parents cannot say that, no, I just said I was joking and all that. They will have to send it. But imagine another case. You scored 85%. Huh? So you'll think, okay, that's only 5%. That smart contract will make sure that you don't get a single penny. That's basically blockchain. The transaction will not happen. But there's another way you can get it. That will be, you go and basically lie down at your parents' feet and pull their legs and cry to them saying, Sirf only 5%, why are you doing this? Or 10% or 15% for that matter. That's going to be a different case altogether. No smart contract is going to work in that case. Parents might give in or they might start beating you. So whichever might be the case, I am sure that session by Dhruv was quite exciting. If there are any questions, is Dhruv where? Yeah, so I would suggest you all to, if there's any question, you might have taken notes. If you want to ask something, Dhruv is here right now. Obviously, he'll be here as well. So you can come up later to him and solve your queries.
You can take all 8 days to think of good questions. I'm going to be here till 28th. So
absolutely.
Yeah. If you're here today, you're listening to this, you can come to me on 20th with your question, which is not a problem at all. So yeah, in fact, I'm looking forward to good questions on the last day because, well, deep thinking, deeper questions. Give me a tough time, guys. Come on.
Absolutely. So, so we are closing in now. It was a long day, but it was really fun. I mean, I don't remember attending such wholesome events that started in the morning, ended in the evening, but so much activities happened at the same time. And dear students, we at IBC are excited. Guys, I'll just take 2 more minutes. I know you guys I just want to leave and end the day. So I'll just take 2 minutes and I want you to hear a few pointers about what we'll be covering tomorrow and overall gist of what we are trying to do. Not more than 2 minutes, I promise. But if you are silent, if you are not silent, then I'll wait and then you'll have to sit. Okay, I think some people want to sit. Is it the case? Perfect, nobody wants to sit. Great, long day. So we are excited obviously about the future of Web3 and potential it has to change the way we interact with the internet. But we are equally excited for you and we are hoping that in the coming days of this entire Hackfest, we will see you at a different pedestal altogether. We want to see you develop amazing things. We want to see you surprise yourselves. by the time you end your journey over here in the next couple of days, I know, a few days is not huge, not a lot can happen, but if you put in the right amount of work, blood and sweat, then definitely you will go out from here at a different level of understanding of blockchain. And trust me, if you sit to anybody in your college, or on a normal day, any tech expert, you will be able to understand what he's trying to speak. At whichever event you may be, you will be able to figure out what exactly he's trying to convey. That is what we are going to tell you, explain you, and equip you with in the coming days. A small gist of what we'll be covering tomorrow. We'll talk about blockchain apps, smart contracts, blockchain oracles, and a lot of exciting things about Polkadot ecosystem. You will be able to access today's sessions on our YouTube channel. We will also be sharing with you some reference material and resources on Discord. So make sure you join the IBC Hackfest channel because all these information will be available to you there. And obviously, if you think you need more information, you want more resources, you can definitely just drop in a message and we will revert with whatever your requirement is. And before I move on, I want to ask if anybody here wants to come on the stage and share their experience of how it has been. No? Too tired? All right, I understand. So I'm your host, Deepak Singh, and on behalf of IBC Media, I would like to thank you all. Let us give a huge round of applause to our students, teachers, all institutional leaders, SPOCs, Government of Telangana, TASK, Tech Mahindra, and of course, Polkadot. A very good evening to all. See you all tomorrow again for an amazing session. Trust me, it's going to be better than today. Same, sir. Yeah, absolutely. We'll be here only for the next 8 days. The same timing will be coming up. The same timing. You guys have not received the schedule? Okay, guys, I think there are some doubts with respect to tomorrow's timing, right? So give me 10 seconds, hold your seats. No need to sit for that matter. You can stand, just give me 10 seconds, I'll confirm, give you the exact time. Yeah, so we will be expecting you here at around 9:30 for the registrations because it takes a lot of time, and the ending will be around 5 p.m. Okay, and obviously we wanted to end a little earlier today, but the Q&A sessions and some other sessions took a little longer than expected. So that might happen. So keep a buffer of 10-15 minutes in the evening today. Once again, thank you all. Give yourselves a round of applause. You have been amazing. Thank you so much. And we appreciate you coming here. We'll see you all tomorrow. Thanks a lot.